All right, here we are. Oh, dual streaming again. How fun. I have it in ultra low latency mode. We'll see how that does. 1, 2, 3, 4. So I was still a couple seconds behind OBS. All right, well, can't expect much else. I think Twitch probably has a bit of a delay too. Welcome to stream 2 of my one stream skull build. It never fails. I didn't even say it was a one stream build until it became comedic. Comedian-y. It became comedic that it was 2 streams. Over the break, I've been tuning VCOs. I just finished rebuilding the X4046 VCO. It's a Thomas Henry design. I did all this point-to-point wiring on it, right? I did kind of like a floating circuit board on some of the circuit elements, because you can pull certain elements from this panel to the front panel in order to reduce the amount of wiring in between all these things, right? So I did all that wiring according to my notes, put it all together, slapped it together, powered it up, and I get some kind of a voltage that is not possible for 12 volts to produce. What the crap? It's like, that's supposed to be a triangle wave. It really doesn't look like a triangle wave. When I go to adjust the frequency, nothing happens. So, I don't know. Am I that inept? Maybe the capacitor that I'm using isn't quite right. I mean, the wave mixer works. I can go between the square wave and the triangle wave. It's just fixed at this super high frequency, and it's super duper negative. It's almost as negative as chat. What the heck? Like, why? I don't even know. I don't even know. What's my glucose level doing? Holy crap. Glucose level's terrible. By the way, Halloween costume on Willow. He's a flower. He's a sunflower. Very cute. She doesn't like to visit me anymore. We have people come to look at part of the basement, so hey, Q23. Did you accidentally hit the enter button? Alright, what's my glucose? What do you mean missing 0 grams? You're gonna get 6 units of insulin. That's what you're gonna get. Alright, we'll let that do its thing. She's not a pumpkin. Oh, you're being negative. I see. Switched signs. I get it. I see it. That was unbelievably hard for me to understand, and I don't get why. She's a cutie. Yeah, she's sunflower. He's posh rugged upstairs. How's everybody doing today? Welcome to Halloween. I guess I have to be Halloweeny today. I'm not wearing an outfit. I'm not messing around with that stuff. I'm cool. It's cool. I'd rather be comfortable. Also, I never properly prepare, so that's part of it. I never properly prepare. Why is this thing terrible? Look, I'm getting negative 15 volts DC on this thing. You can't do that. It's got only plus minus 12. Why are you like this? Nothing changes it. I wonder what control voltages do to it. Let's find one that's actually changing. Okay, it just kills power for everyone. Yeah, because it's putting like weird voltages and everything. I gotta check this thing over. What the heck? There's some really kind of crazy shit going on. This is the easiest one to build though. I just didn't get the front panel PCB. I made my own and I made it small. It's the same circuit though. All the same elements are there and it should be wired exactly the same. It's just something is very, very wrong. Very, very, very wrong. Something, right? I'm gonna cough, 1 sec. Okay. Yeah, apparently the music isn't muting when it goes to YouTube. I'm just gonna start publishing, bugging the firmware. 4046, TL074, TL072, and then a super matched transistor pair. Right, where'd that go? Right there. Yes, perhaps it is the code. I don't know. Should I just start taking VODs and just start uploading them? It's gonna cause chaos on the YouTube channel, but I need something there, right? I should be putting up content. I can just go back on the previous VODs that I have recorded on this computer and just upload them straight up. Yeah, it's got... No, it's actually got an FPGA that's emulating a 7400 series. Hiccup. I have some FPGA. I really need to learn FPGAs. I think they would be fun to do like something with. I have this tiny FPGA that's like it's the size of an AT Tiny, but it's an FPGA. It's like a really powerful little development board, and I've had nothing to do with it. I was thinking of making it run. I mean, it could run a modular thing. It could do like a modular rack thing, or it could do like, I don't know, text on video. I don't know. I was gonna do FPGA audio with it and have it do my microphone, have it do the microphone preamp stuff, but I like the preamp that I have. Celia Russell, subscribing for 72 months. So when I say I've been streaming for a while, yeah, there's proof. 72 months. All right, what is this? This is a gallery. I already showed Willow's Halloween costume. I am a sunflower. What is this? What is this? There are no rules. It's just ridiculous. Jeez. 72 months, huh? Damn. Yeah, so I don't know what I did. I don't know why this thing has become like a voltage multiplier. It's become a voltage multiplier. Yeah, he did the swapperoo today. That's not the same person. There's a bunch of videos of people commuting with their cats like that. It's crazy. People just like put the cat on their shoulders and just trust that it's gonna hang out. Marbles works, by the way. I put a lot of work into that actually, behind the scenes. Found out that there was an entire pin of the reference voltage regulator that wasn't soldered. It wasn't soldered. There was no solder on it. It was just floating, pin and pad. And so when you'd flex the circuit board, it would lift away enough that the whole thing would die. And then you'd unflex the board and it would come. I only discovered that when I put all of the bolts onto this. And it turns out that the voltage regulator is just a little bit too tall. Halloween. Oof, that's a tough one. That's a tough one to endure. It's really kind of a challenge to sit here and allow you to say such things. He's very proud. Look at that puppy. I had to hold up the flower petals. And I think that's clouds, yeah. That's the Simpsons intro. We had to cut it because we didn't have time. We didn't have time to order the larger one. And I tried to put it on her and only her snoot went through. her big round head did not fit. But yeah, so that's her outfit. She's the one who's dressing up today, not me. We are here on the precipice of a landmark birthday of mine. Ugh. I don't want any trouble. I don't want any hullabaloo. I don't want to make it like that, you know? What do we got? What do we got? What do we got? Hopefully this audio doesn't get completely sniped by YouTube and their frightening algorithms. We'll see. And then I guess I just need to go back in time and just start uploading, but I don't know if I should go to a point in time and upload up until now, or if I should just go backwards and just keep listing them and say this was broadcast at this date. I should probably put the broadcast date in the descriptions of the ones that I've already done, but that requires work and forethought. I don't have any of that ability. Yeah, Marvleps works. That just means I need to go back on the other, what do you call it? The other, modules. The other Mutables Instruments modules. They all need tuning. So I'm gonna probably spend a little bit of time on Toil's YouTube channel, checking out how to do that. I don't got no idea. And the problem with this thing scaling up and down, partially because the reference voltage wasn't there, but also there was an error in the op amp. One of the op amps in the circuit wasn't producing the right standing voltage, and what that would do is set all of the other control voltages to a bad area that ended up causing an override of what the knobs were doing, which is wild. It's just crazy. So I had to run numbers on the circuit. Here, I'll show you. I will show you the work that I've done over the past few days. Math. It's just math. It's all just math. The op-amp circuits have a 10-volt reference that's being summed along with the input voltage. So there's two voltages that are going into this thing. And so one of them is minus 10, the other is plus or minus 5 volts. So when you take 33 out of 200 and 33 out of 100, because those are the resistors the two parts of the circuit have, and you add those ratios, you apply those ratios to those voltages, you get 1.65 volts when this is at zero, when the 5-volt input is at 0 volts. So I was looking for 1.165 volts at the exits of all 4 of the input op amps, and I found 1.9 volts at one of them. So that the ratios here, right? 33 over 100, 33 over 200. Those are in order to, viewer count halved. It does that when you've got like 4 viewers. When you have very few viewers, it'll jump around. Maybe it's because I said the word math. When you apply these ratios to these inputs on an inverting op amp, it will have a range of 0 to 3.3 volts. So 0.165 is right there in the middle. And so if you get a negative voltage, it'll get closer to 0 volts. You get a positive voltage, it'll get closer. Actually, I think it's the opposite way. More positive towards 5 volts. You get positive 5 volts, it's at 0. If you get negative 5 volts, it'll go up to 3.3 volts. So that turns it into a 3.3 volt analog signal that the microcontroller can use. It's simple math too. It's not complicated math. So I really like this method of having the negative 10 volt reference coming in there for control voltages going in. I will copy that if I do something that has control voltages that will apply to it. It's not 8 volts though. Some control voltages go up to 8. But since the MCP 6005 op amp that are used in this thing, that only gets up to 3.3 volts. So if you get a higher voltage or a much lower voltage, you get negative 8 volts, it'll just go down to 0. It'll just top out, it'll clip. Folks in company can order shipping from company early. Company, except the one that was meant to send to 5.5, sent me shipping notices on the 23rd. There's a delay from Raspberry, none of them sent it yet. Oh, so they're like directly, yeah, you didn't actually buy it from that company, you bought it from Raspberry Pi through that company? That is pretty annoying. But yeah, then somehow I was getting 1.95 volts. Didn't make any sense. And I actually removed components from the circuit in order to test them, and I found that one of the resistors was bad. I had a unity gain, I had 100K instead of 33 by accident. So that set one of the 4 inputs to completely crazy, crazy town. So that was a big deal. I fixed that. but then going through like individual component values to see if it would get me anywhere near 1.95, which it did not. And so the final conclusion was that the op amp was actually bad, because I checked everything. I looked for shorts, I looked for little bits of like flux and material that might be changing the resistance sort of behind my back, but it would have to change a pretty great deal in order to affect those ratios to get me to 1.9. So was there like a spurious voltage coming in? None of that. Looked, checked, cleaned everything. Final conclusion, oh my God, I'm gonna have to remove the chip. So I got the hot air out and I replaced the chip in about 5 seconds, because hot air is just like cheating. Once that new chip is in there, perfect, works perfectly now. So I don't have to recalibrate, because the op amps for the DAC were the problem. And then there was a problem with this channel, and the channel all the way on the right it was acting funny. But then if you ask somebody why that channel's acting funny, they say, oh, well, those are just based on the clock signals over here. So you need to make sure that there are ticks being generated and ticks are being distributed to both of these, and then you'll see activity over here. I'm like, oh, maybe I just don't know how this thing works, right? Maybe I just need to twiddle the knobs in a particular way in order to get it to function. And I did, and then things changed, and it was like, okay, maybe it's okay. And then I noticed that it was just completely wacky. Like something was wrong with that channel, but it's really hard to display that. It's really hard to display that to people unless you put it in the mode where all three of these get the same levels, and then you bias it back and forth. This channel would like lag or not go as hard into the paint as the other ones would. So I took the front cover off again, went all the way to the op amps over here that are responsible for the 4 outputs are done with a DAC, digital to analog converter, and I hunted around at that. All I did was touch the solder with the soldering iron a couple times in a couple key locations, because I didn't have full circuit analysis in math for that op amp. I could have done that. But I didn't. Anyway, touching the solder fixed it. So what a pain in the butt this module has been. I can't believe that this regulator does not fit. I wonder if I should flip it over to the other side. It would no, it can't, because that'll collide. Darn it. So the music I'm playing is one of the ancient mixes that I used to play at the beginning of streams, which is a 9-year-old set from Costa Rica. 9-year-old music, man. I can play anything I want. Hold on. I can play anything I want, and I'm defaulting to my too obscure to be copywritten by Twitch list. We'll see whether, well, Twitch isn't going to do anything. I mean, it would be nice if I could just rely on them to mute stuff again, but they send me notices now when they mute stuff, and they change your settings. So I'm just not messing with that anymore. Yeah, it was recently after they had invented music. So received the Raspberry Pis before the 23rd, could ship it then, but Raspberry sent it from the factory company's 23rd. Jeez, I don't know. That's a situation. Everybody is champing at the bit to get a Raspberry Pi 5. Hey, Brink GG, how's it going? Everybody's champing at the bit to get a Raspberry Pi 5. I don't have anything to do with one. I mean, burn the subs is the most complicated piece of code that I have, and it doesn't really even need to operate on a Raspberry Pi. Raspberry Pi just made it so I could program it in Python. And it handles all of the like memory watchdogs and stuff like that you wouldn't necessarily get in like a heavy microcontroller project. But I could just as easily run that whole project on something else. I have an ESP that's able to get on the Twitch API. So, and actually I could probably mostly run burn the subs through a Raspberry Pi over here. I could get the refrigerator and the Node-RED setup to do all of that. That's a big thing on the list that we need to get to, but I'm busy building a cute-looking skull speaker, so I have other things I need to do. Micro Center has Pi 5s in store. I could just go get one then. That would be maybe like an hour trip. Less than an hour. It's not. It would be an hour sum total, like until I get back at the desk, because it does take a little longer to drive there now that we've moved out into the sticks. but I could take a train. I could take a train from my station to St. David's and go to the Micro Center there. It's a little bit far for walking distance, but not that bad. No, that's not that far. No. The station is up the hill. Yeah. Why did you get 3? I can't function on low sleep. I can't. I didn't sleep well last night. I had gin. I was like, well, I'm gonna be 40. Fucking birthday is like in my brain space right now. I hate it. Anyway, yeah, 3 hours. I can't do anything on 3 hours of sleep. My brain just shuts down. Beetles. I got stink bugged yesterday. It's not as cool as getting stick bugged. I was sitting there with the dog, petting the dog, and a stink bug very loudly just goes buzz and buzzes away. And I was like, oh no. My shoulder smelled for the rest of the day. Like chemical smell. It's these fucking stink bugs, man. They're taking over. Gin can do it to you. Yeah, I didn't have that much, but I still feel like I had that much, which is a bad idea. Just a bad idea all around. You can say youngsters all you want. It's still a landmark birthday. I02. I02? Oh god, I'm looking over at that other screen. It's like a big close-up of my dumb face. Oh, I hate it. I hate it. the video monitor window that lags behind. Just getting into the chair, I just see myself. That's part and parcel of my entire stream setup is designed around not having an absolutely ridiculous spine, right? I do not shrimp. I do not shrimp position here because the video monitor windows are all the way up there and my microscope is also up there. Everything that I do erect, as in my back. That's what, that can't be misconstrued, right? That can't be, I want to finish the skull today, just because I want monitor audio out for the Euro rack before I get too far into the weeds with all this stuff. Because we have more module tuning. There we go. That's what use your language words. Raspberry Pi Pico 2. We'll keep the blinking lights for a minute. So I also repaired Julian's marbles as well. His had much similar issues to this one. It had a dead op amp. Wow, YouTube is very far behind now. Why is it so far behind? Yeah, I had to remove an op amp and then investigate the solder everywhere on the thing. And I'm pretty confident that it works now. And both of them work. There's no longer that weird problem, because I think the dead op amp was the reason why this one's timing would change gradually. Basically, the input amp, I didn't do any testing on it when I first built them. And that was apparently a huge mistake. And it's something that I now need to do to all of the other mutable instruments modules, like Clouds. Clouds is a little nicer though. Clouds is, people do like projects with Clouds. They reprogram it almost completely. We do need to find a larger voltage regulator though, because that thing gets hot. Yeah, it took a lot of going over the solder, and there was a bad op amp in both modules. The same op amp was bad. I don't know why. And it took running the numbers. I had to actually do the summing equations that the op amps use in order to produce 3.3 volts to 0 volts in reference to incoming plus minus 5 volt control signals. And it all works out to 1.6 volts at idle. And I was getting 1.65 something. And one of them had 1.95, which is not the right voltage. No, sir. I can't even hear the music. Is that mix over? No, it's still going. This one is so much easier to program. It's got the header on it, and then you've got 2 buttons here in order to punch whatever code through. I probably could have put the header on the other side. Would have been safer there. But Clouds is a much easier little audio engine. Yeah, math only really works off stream. Actually doing math on camera is impossible. Absolutely, completely impossible. So I don't have any reason to believe that this thing is bad. I just need to explore any bad solder joints, and I may need to go through and figure out how these circuits are functioning with everything else, because I think this uses different reference voltages, and it looks like we have TL072s as the op amps in here. And then I need to tune it so that the voltages that it outputs are what it believes it's outputting, so that it can, you know, properly be. Clouds is more of an audio thing, though. Oh yeah, and then there was that. R27 is a special value. It's a special summed resistor. It looks filthy because of the flux. I don't like these white circuit boards. I do not like them. But yeah, this part is overheating. I don't think I have a 3-volt regulator that is that form factor. Slightly higher amperage. Have to find one somewhere. I wonder if I can find one now. While we spool upstream and I collect people. No viewers on YouTube, of course. I don't know how that works. I think I need to, well, I need a body of work on YouTube in order for people to be able to find me. So we need to just keep streaming forever until you die. Is there a big 3-volt regulator on you? No, you wouldn't be that classless. This is a router that broke. Now, a router would have big or very specialized voltage regulators. Yeah, the power button is broken. See nothing. Do VOD. YouTube lags behind though. Yeah, use the VOD command. I'm not at the keyboard. I can't do it. Which among you uses a big 3-volt regulator? I'm looking. The only chance is the scraps that I have. I'm gonna start. That channel's gonna be chaos for a little bit though, because I'm gonna start uploading a ton of stuff to it. All the VODs that I keep on a little hard drive. What about you? BMW thing? No, nothing of the sort. How about a drone? I think a lot of stuff really use that form factor of voltage regulator. I don't see them often. This thing is it's a 5-volt res. It's a 7805 just sitting right there. This thing doesn't even use 3 volts. Oh, and I found out on this thing, on the VFD, I don't know if Gonad's still here, the filler neck has snapped off. So this thing is fully dead. There's no getting this back. Unless I want to play around with gas, but I don't think so. Yeah, I'm looking inside of it right now. Kind of sucks. Yeah, they're white. There was a little bobble on the end here that snapped off when I was tossing this thing around. At some point. Yeah, that's these guys right there. Those would be silver. Which is, kind of a shame, because this is a pretty cool VFD that I now no longer have. And I used to have 2 of them. I threw one out. I kept this one because it has all these buttons on it, but never ended up using them. I don't think I have anything that has. Oh, I see. So that's actually there in order to get any tiny little bits of stuff that happen to be floating around in the vacuum. But when you snap the bobble off, it gets inundated with stuff. So we tried to update Clouds by giving it audio, and it wasn't quite working. So I think there's still something bad about this, and I need to like get in there and really observe everything. I'm not sure if there are test programs that people have made for Clouds, because Clouds is interesting. There's like a whole blog about rewriting Mutable Instruments code into Clouds, and doing your own thing. After vacuum is pulled through the nipple. I don't think you're allowed to say that. That's like, there's like morality laws. We do need to tune the 3340 VCO too, so we've got a lot of rack stuff to do. This thing just flat out doesn't work. I had it on earlier and it was like a negative 15 volts, which is weird because it only takes plus and minus 12. So what happened? I guess my ground is suddenly a weird voltage? I don't know. Yeah, I'm gonna have to figure that one out. Actually, I think I do know. I think I did reset the ground. I think I connected two things that shouldn't have been connected. As in ground level and... No, that's all ground. That's all ground. There's negative voltage. I haven't been treating that as ground. I gotta do a once-over on all my schematics and stuff for that one. It's disappointing because I was careful about it, and then it blew up. So... At least I didn't take out the microcontroller. When I was poking around with Julian's marbles, what happened? I put a new op amp in over here, and I put it in backwards. So the MCP 6004 was referencing 3 volts and ground, and it put the module into like a programming mode. Weirdly, it was like the LED, all these guys didn't turn on, and so I flipped the chip back over and hoped everything would be okay. But when I powered it up, it was in a weird state. It wasn't powering up fully, and I was, oh shit, I blew up another microcontroller. Those are $12 right now because they're getting rare. $12 a micro, and I was like, oh no, you know, I basically just gave myself a bill. But I hooked up the programmer, and it was actually communicating with the programmer, so it did work once I reflashed the code. But yeah, that was scary. That was scary. All right, I want to get to work. Let me get to work. What are we doing today? Get this out of here. Go to this cam. Move the window over there so it looks like I'm looking at you. Put marbles in the rack because it's done. Right now the rack is the storage space for modules that are done. So there's 3 in there right now. I have so much work to do. I have so much work to do. And then the music. Where is it? I put it right here. Oh, wait, no. Bring chat over to there. I'll just fade this out. There it goes. Hey, how's everybody doing today? I'm your slightly wet-looking host. Oh, bother. Welcome to my shop. We're working on a skull speaker because I need some kind of line output, and I got really sick of dealing with this thing's original electronics. Bought this on, I think it was an Amazon deal day or something like that. I'm moist, oh bother. Yes. Yeah, I bought it, I think, on like an Amazon deal day. It was probably like 30 bucks. And it was good. Like, I used it as a LAN party speaker. But the problem is when you turn this thing on, it has a Vincent Price sound file, basically the laugh from the beginning of Thriller. Ma ha 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 ha. And it did that full volume. So it's like a 4-ohm speaker that's like that big, laughing at you full volume with Vincent Price. It's just like, stop it. I want a speaker that I can just turn on and leave around instead of having one that is battery powered. So we took it apart and we took out all the internals, and then I started stapling electronics to the top of this thing. We need to wire this up into a circuit. We're using the venerable chip I've never heard of before. Apparently it's just like one of these chips that people use for speaker projects all the time. Let me open up the schematic. The schematic looks like, where's my stuff? Where'd my OBS go? Okay, there we go. Yeah, so the schematic for what we're building looks a lot like this. No, looks like this. Super simple, right? This is the simplest of the designs. You typically have the 1 in 4007s on the up and down of the speaker in order to prevent clipping. If your audio goes out of spec, then it'll just dump it to power or ground through the diode. And then you have a couple kilo ohm resistors in there, probably looking like they're producing some kind of a unity gain setup here. I'm not totally certain about that. I mean, you would have 1K to ground from minus and 1K feedback. I think that's no, that would be inverting though. No, non-inverting. That is non-inverting. So non-inverting amplifier simply looks like this. Oh my God. Non-inverting operational amplifier. One resistor to ground, one resistor as feedback going into negative, and then your input goes into positive. That just makes a non-inverting, and then you have your two resistors are the same value, so that's unity gain. It mathematically, you know, yeah, that's what goes on. Okay, so anyway, that's how they have this configured, and it's just very, very simple. Now we actually have two voltage levels that can go into this. I would have stereo and mono from the synthesizer. How would that work? Well, we do some kind of like a summing amplifier. A summing amplifier like this. Basically just your input resistors are scaled. So we need a ratio between rack, modular synthesizer, sound signal, and consumer, I guess, line in. Line in, I think, is up to a volt, right? Line in voltage level. Approximately 1 volt, 1,000 times greater than the mic level signal. What is that? Oh, look at that. And then we need a Euro rack. Excuse me. $5-volt peak to peak. Oh, God. Eurorack signal levels, though, are typically much higher than the types of signals used by other gear. Eurorack signals from an oscillator, for instance, swing between -5 and 5, 10-volt peak to peak. Eurorack modules produce standard part of what keeps Eurorack functional. Hey! So they can go out of spec for that, but if we're 1 to 5, then we need a resistor that is 5 times greater. We just need a 5K. So we'll put a 1K. Actually, hold on. We need to bias stereo into mono. Do we need anything other than, can we mix them like that? Now they're using 1 kilo ohm, but because of the amplification, I'm thinking maybe we need to like do a 0.5 kilo ohm, or do we need 2 kilo ohm on the two inputs to have them? I think that's how that works. So we need 2 kilo ohms, and let's just draw it. Let's draw the circuit that I'm thinking of. And that way I can plug in either Eurorack stuff, paint, and then snip. I'm just going to go snip-it-ish. And then we're going to do, how's that work? Why do we have a 1 kilo ohm to ground, though? Because that's just going to make us a voltage divider. What is that 1K to ground doing? Well, we've got, so we actually have the 47 microfarad is taking it to DC levels. So I guess if we do everything in front of the 47 UF cap, because that just takes it down to ground, centered on ground, and then that would be 0.5 volt plus and minus. And then what's the 1K there doing? It's reducing it more. So we would basically have, instead of this, here, sorry, simplifying electronics. Instead of that, we have 2 audio inputs. One of them has 2 lines on it. And then prepare yourselves for how awesome I am at drawing schematics. Put a dot there. And then these are 2K. I mean, I'm guessing 2K because that would work with the feedback resistor? No. right? Non-inverting summing. Yeah, this is what I suspect. Okay, and then this one is 5K, and then all that nonsense goes into our our potentiometer. Now, how did they do that in the other one? Did they put it on the wiper? I think they did. I just do like one of these. Actually, I can do volume. That's volume and power. And actually, that is a dual. Well, I have one that is a single. I mean, it's a mono speaker, so we don't really need to use. Well, I guess I already installed the whole thing. I have a mono one. Hold on. Maybe we can swap in the mono one. Because if I ever need a stereo volume controlled potentiometer, and I've used it in something already. Oh, no, wait a minute. This one has. Well, hold on a minute. This one has a switch, but I don't know what's being switched. I guess we can take a potentiometer to it and check. Oh, but this doesn't have an indexing. The indexing pin looks like it's been snapped off or something. So that's liable to turn in place. Dun, dun, dun. Let's just check to see what it's doing. We'll get to actually building this thing once I have confidence in my parts. Okay, so the bottom, I think, can be used as a switch, because that is not changing. So this one's probably normally closed. Yeah, and then click. Huh? Oh, that's just always connected. What? Wait, what? Huh? Well, it looks like it was being used from this end to this end. What's that about? Same deal. Okay. All right, so I can go end to end on the bottom one, and then let's see if the top one is a pot. Yeah, it's like a 6K potentiometer. Okay, cool. All right, that works. Total is, yeah, 6K. All right, yeah, we'll use this one instead, even though it doesn't have all the hardware. All right, I got plenty of the other hardware. So that makes that a 6 kilo ohm. Oops. I don't know if I'll use it like this though. But that way I'm using the right parts. I'm not using up a dual potentiometer for a mono signal. I don't know about all this crap. I don't know if this is good. But I think it's okay. It was backed up by a couple of other circuits. I would love to have a clipping indicator on this thing though, and have just an LED sticking out of the skull. But that would mean, I believe, that I need to put another what do you call it? Another op amp on it, which complicates it, which would take some time for me to do. And yeah, I don't know. I think maybe this is just better. Yeah, I'm looking all the way over here because that's where I have the OBS window. I'm just making sure I don't look too out of place. Yeah, all right, let's get to work on this thing. I mean, we got a little bit of work to do here. I got some stuff to put together, so we might as well just get started. Now that we have a plan, we stick to the plan. Stick to the plan. Why are there no notifications up on my phone? Wait a minute, what's going on here? Did you shut off my pump stuff? No, it just decided to like not split. The new version of Android is wreaking havoc on my insulin pump software. It's been suspending it in the middle of the night, and then I'll wake up hyperglycemic and all uncomfortable because I have to pee. I don't know how to get Android. Is there a way you can get Android to like respect your boundaries? Oh, wait a sec. This one's a single one too. Oh, we'll just keep using this one then. Never mind. No reason to rock the boat on that. I've already made the extra no spinny hole, so that's one less job. One less job. All right, so disable optimization for the app. How do I do that? We just search settings for optimization. Here's Willow's Halloween costume, by the way. She's a sunflower. There's more pictures of her on the Discord. All right, let's see here. So settings, battery. I'm not using battery saver. Yeah, I think I disabled all that stuff when. Oh no, it's just. Well, no, use battery saver off. So adaptive battery is off too. You disable all these settings when you put the health app on here because it needs to have priority of running all the time. So yeah, I don't know what it is. It's in the middle of the night. It'll stop it from functioning. It's done it a couple times already, and I basically now I just wake up and check to see that it's running. All right, let's get to work. We gotta build the circuit. We gotta build the circuit already. Oh yeah, I'm gonna need two more resistors on this stuff, and I guess I'll put them in just like right here. And so that means we need the drill, which I've still got in reach. It's just right here. So I'll put the 5K here, and then the two 1Ks here, and then we'll do a couple wires, one wire basically that goes all the way over to here. Well, two. We need ground, and then power will come over to the main chamber through this hole. All right, so the biggest drill bit that I have in the miniature drill bits snapped, so I got to use one below it, which is fine because these resistor leads are small. And then I'm going to put, let's see, we can do 1, 2, and then put the other one. That's tough. Well, the solid leads of the resistor are going to be sticking out the bottom here, so I might as well do this just upright close to the plug. Actually, let's get a reference here. I had references. I think I chopped up that resistor in order to make that VCO, and it didn't work. So we need 2 kilo ohms. The Extreme Day Bartholomew? I don't know who that is. Who is that? I hate them. I don't know. I don't know anything about them. What kind of content? Sounds interesting. 5.6K. That's very close to what that's close to the 5K that I wanted. These are 1Ks, 100K. I really don't like these resistors. They're too thin for my stuff. 68, 82, 22, 33, hut. Oh, wait, there's 5.6K. What was that other one? 5M6. Oh, that would have been bad. And then 2K2. You can't get the values all the time. I mean, I guess you can nowadays, but, you know, sometimes you have to put in a near enough as makes no difference value of resistor. Form of Microsoft employed today was about eye tracking in the next-gen VR headsets. Cutting-edge tech. Huh. Oh, that's neat. That's pretty cool. Yeah, we strictly do not deal in unobtainium. I bought with my own dollar the Rygol, the latest Rygol, in the slightly spicier flavor. That's going to get here the day after I die of old age, because the internet considers 20 to be old. Yeah, you get it as close, near enough as makes no difference, right? That's the standard practice. All right, let's start here. And this one needs to be nice and close to the body, but not too close. It's kind of fun having to drill stuff. It's like actual breadboarding, when they used breadboards, as in a board that you would put bread on. And electronics used to all have bases. They would have a base that you would screw into the breadboard, just a wooden board. Use of eye tracking and AI to super render what the user looks at, while peripheral vision gets peripheral render. That's going to be really, really annoying to watch a streamer use. That's going to be really annoying to watch a like for the other people in the room. That sounds like obnoxious technology. It's just like it's so tiring to watch a streamer do VR because there's these micro movements that the head makes. Happy Halloween, Mahalo. The only Halloween thing that I've got, other than having a spooky skull speaker, is my bubby wore her Halloween costume today. I only have pictures because there's somebody that's going to look at her furnace in a little bit, so I had to lock down the shop so that the dog would usually hang out with me during that time, but I don't want anybody without consent in here on camera. I guess she didn't specifically give consent. We had to cut the sunflower because I bought the thing for a small dog because nothing else would get here on time. But yeah, she's got her little cute little bonnet, little flower bonnet. It doesn't stand up either. I had to like hold it up in the pictures on the Discord, which is really annoying having to hold it up like that. If there was one stitch in between the petals, it would probably stand up on its own. So I don't know. Maybe I can refine that for next year and actually order the right thing. Gotta be careful not to snap these bits. These bits love snapping. They're very, very small and they're hardened. Corgi in a blanket and Corgi in a coat and bananas for some reason. Sure. I suppose that makes sense. That makes sense. Come on. There it goes. We need 2 of them down here. I like doing this because I don't really need to measure all that much. The resistor leads will kind of do their job, and I can just stuff this stuff in. Is that going to be in the seam? No. Just enough plastic there. Okay, now my thumb muscle's starting to hurt. There we go. Okay, so these are the last of the components that we need to put in this thing. Unless I decide to put an LED somewhere, which I should. Which I should by all means. I'm going to put the drill bits away before I end up breaking another one. There's this ratio of time between drill bit exposing time and drill bits being exposed where eventually, statistically, I am going to break one of these. So very careful, put those back. This is a terrible container, by the way. There's nothing holding that top on. And these barely keep the things in their sockets. It's like, if I had to travel anywhere, I would not have bought this drill bit set. I need to get another one. Find out where I can get tiny little miniature drill bits. The tiny little miniature drill bit store, maybe. Okay, so 1 resistor, 4 Euro rack volume levels. Oh yeah, Euro rack. Calling mom. All right, do that one, and then we get 2 of these. I know, yeah. It's a very small store. It's a very tiny little place. Do this. Got more of these resistors up on the top of the skull. Archimedes mini drill. What I'm supposed to have is a tiny miniature little drill press. That would be what your typical electronics dude would have. And the tiny little drill bits are for the tiny little drill press. And it'd be an extremely high speed drill press for drilling out vias and stuff on circuit boards. But I just have them with a little hand drill. Which is also why they broke. That's why it's broken, is because my tiny little hand drill has betrayed me. All right, so bending the leads down. We'll hold the resistors in place. Let's see, that one goes to there. That's going to be tough to solder. Well, got to bite the bullet at some point and just get these things done. So let's bend this lead around, get it to the right spot. I'm going to use tweezers for this. Let's get in here nice and close. This is going to be annoying. This is basically what I was doing with the VCO, is bending these sort of floating circuits, the exposed circuit kind of deal. Get in from behind here. So I took the speaker out. Okay, like that. And that up and along. And then I pinch those two together and solder them. Can't really get in there to pinch it, though. Maybe I could just selectively just bend it on my own. And bend this end upwards. And I got a nice little post there. You just wrangle into position. There you go. This is going to be easier done through the speaker hole, isn't it? Yeah, that way I can get on top of it. Can't see anything because my light's being blocked. Let me get my light back in here. I should just attach a Dremel to my miniature arbor press. That way I'd have a little tiny circuit board drill, but getting it out would mean that I'd need to remove that arbor press, and that arbor press is the counterweight for my microscope. So I can't really do that. I guess if I had a metal desk as the top desk, it would be much easier, because then the Naga arm would actually attach. I can't get in there and hold this closed with anything. Archimedes drill. Oh, like that. Oh, that's cool. I could probably use one of those. I'll just get my windows figured out here. Figure out my windows, make sure I'm looking at the things I'm supposed to be looking at, because I'm going to need to be able to... I want to get decent shots of the stuff going together. I mean, it's nice looking, and it's good content, you see. But, like, I can't... It's, like, impossible for me to even, like, see this. Ugh. All right, we're going to bring you guys in real close, and we'll focus the camera. That. And then everything's going to wash out because of the plastic. I got a lot of light in here, but I guess I'm going to have to put a finger on the resistor in order to hold that like that. And then, because when I let go, it sags. So I'll just hold that like that. Let's get the soldering iron in here, and then solder. I don't know how that's going to work. Maybe I can just pre-tin them in the location that they're in, and then I'll bring the iron in one-handed and press on the resistor. And this is why this stuff takes so long, because I explain everything that I'm doing. There we go. So that's our output. That's ground. We need to get these two grounds to be attached to one another. I haven't really clipped any of the resistor leads. I guess I could just use a sacrificial resistor lead. Hate to do this, but oops, that's not even. Yeah, just grab something where I ordered a ton of them. Are these 1Ks? I don't think I should take any more 1Ks. Take like a 10K. These are, yeah, these are 10K. Just grab one of those and just use its lead to go from one spot to the next, and I guess I can get just a little bit of an angle on those. This will go up this way, this one goes up this way. Those go to the second half, and then I need to solder that without totally melting the case. Clip that end a little bit. I kind of want to actually bend that to go alongside this other one just so that there's a little bit more to solder than just a dot on the end. So grab that and bend it upwards haphazardly as to make a big rounded swoosh. Damn it. I didn't want to do that. I didn't want it to look like that. It's all right. That's all right. That's all right. That's all right. Yeah, I'm just going to clip both of them, actually. Oop. And then those need to go to right and left channel over here. But that should be really easy to do, actually. We're just going to get this half of the skull built. Ready to go. That's real close to the plastic. Oh well. Go. And then push them together. Now that one's stuck to the plastic a little bit. I want it to move over. You two make nice. That's a little sloppy, but whatever. And then I take a sacrificial lead. Just bend the ends here a little bit. That's not as much as I wanted. All right. And then I'm just going to float that from point to point. So let me pre-tin the 2 points that I'm floating to. Kind of hanging out in space. Where all the vibrations are going to be. That's all right. This speaker should last a little bit. Not too long. It doesn't need to be long-lived. It's already dead. It's a skeleton. It's dead. Oh, that's not pointing in the right direction. I can take... Oh, I could just do this. There you go. So now I'm just gonna pop those two together, make sure my shot's good. Been quiet around here lately. Wonder where everybody is. Well, it's Halloween. Everybody's having a good time, right? You guys don't really... Do other countries celebrate Halloween? You guys don't do the Halloween Eve kind of stuff. What about your skeleton industry? Sad, sordid state of affairs. All right, let's see. So now, this one's going up to that post. So I can just go like this. I'll do the same for this one, only a little earlier. Of course, I'm going to have to kind of... It's not going to be as clean of a path as I wanted it to be. Just because these have to reach their destination. It means I need to take them and manipulate them a little. There you go. That worked out okay. Watching and compiling GCC. Oh, the excitement just sparkles from that sort of a task. Well, there is something satisfying about compiling, though. That's you know, that's at least something. How do I get to that one? I guess I just got to kind of maneuver. I got to rattle my bones. All right, and then push that into the tab so I can solder it properly. A giant white hand is on the main part of the screen. All right, so those are the input resistors. Hopefully that keeps the volume level at a decent clip. That's not really soldered that well. Hold on. That's a little better. All right, so that's the circuit so far. This is all we've built. Everything else has just been collecting parts. So there's going to be 3 wires that go from here. So maybe 1 wire down to here and then 2 coming back out. And then we have our power, we have our ground, we have our audio signal. What's that doing? That's our other audio signal. Actually, wait, these get mixed. And how? I'm not finished yet. Oh man, I should have gone... Ah, that was dumb. It's all right. That's all right. We'll just make duty. I mean, make do. Make do. Make do is what I meant to say. I'll just solder that like that and melt the crap out of the plastic. Yeah, I guess I have to. Ah, that was dumb. That was dumb. No, I lost it. Wait, where'd it go? Oh, there it is. Yeah, he is. All right, let's get this back over here. I can smell that plastic. Melty, melty. Uh-oh, that one, that went wrong. I had the two wires resting on one another, and then they slipped. Is this totally blurry? What's going on here? All right, let's do a little bit of that. Do a little bit of this. Oh, they've got a big bridge holding them together. All right, let's see if you do that. Get that, just a little bit of solder on there. Like as soon as I go into solder it, I accidentally bump it, and then it opens it up. I guess that's all right. Oh, damn it. Melted the plastic. Yeah, it's the only thing with soldering around plastic like this is that you move your hand a little bit, and the soldering iron will make contact with something plastic. You barely feel it. You smell it. You smell it. Smell the damage. All right, so that's our now total input part. Those are all connected. All the inputs are summed, and then we have power down here. I got the two big solder blops on that. Before I go and wire that, we should get the other half of the skull put together so that we have all of our connections done here. So what do we have? We've got two 1Ks. We have where audio is going to come in over here, and then we have our power switch here. So power's coming in here, audio's coming in here, we got ground coming in here, and then we go into our speaker circuit, and we have a JST on the speaker circuit that'll plug across to the speaker. So the speaker circuit, why do I keep going to the wrong? I keep going to the wrong scene. Speaker circuit, audio amplifier using TDA 2030. Let's just get from one end to the other on this thing, I suppose. I've got the diodes in there. I've got three 1Ks just sitting in like a holding position. The 1N4007s are on. The multiple connections for them are going to be a little bit of a challenge. But I guess it's going to be a bit of a bird's nest in here. So audio comes in and goes through the 47 UF, which is not that one. That one's 100. This one's the 47. So audio from the potentiometer should go through there, and it goes into the plus side. So it's actually the opposite side. It's this side, and it's out here, and from here it needs to go to the 1 kilo ohm resistors. So what I can do, let's see, where's this one going? This one's going to power and ground. Oh, that one would have been better, like way over here. That's just gonna have to, that's gonna be a weird connection. Okay. Should I flip that so that I've got the two grounds for the TDA and this thing right there? Probably. We'll figure it out. So if I do a floating circuit, I didn't really plan out the positions of these things, so I'm kind of scrambling to make sense of the circuit. Because the 47 goes to one resistor to ground, one 1K resistor to ground, so that will be, I suppose, this one. What is this one doing? This one's off of pin 2. There's two off of pin 2. One goes to ground, and the other one goes to pin 4. So this one would have to loop back and go to pin 4, probably drill a hole like right there for it. So that would mean that this one would go to ground, and then the other one, actually these two can go to ground. So that's actually kind of convenient. So I can do both of these go to this pin here. And then one of the 1Ks is on audio input from the 4.7, which is here. So one of the 1Ks will go here to the 4.7. So I can just take that. Actually, wait, I'm going to undo that bend. All three of them don't go to ground. Now, one of them goes to feedback. So this one will go to feedback. And then this one, okay. This is obnoxious, but it's actually a pretty easy one. The circuit. It's not that crazy, but it's getting it all arranged without a plan is sort of what I have to do now. I got in here without a plan, and now I'm paying for it. There is one on pin 2, which I guess could be both of these, and then the 2 will go to ground. All right, let me just think about this for a second. Actually, yeah, all of them go to ground except for... I'll just take this wire here and bend it alongside of this one. And this one will go this way and just link up with the 4.7. We'll just do both of them like this. I don't know. We could be sloppy. This is inside of the skull. Nobody's going to see it. I'm not going to broadcast this to hundreds of people. Wait a minute. We just did a bunch of really hardcore troubleshooting with the marbles module, so it's nice to kind of just do something plain and easy and simple. Simple as. I see it. I don't. That's the problem I'm having, is I'm not seeing this circuit in my head. You can really complicate this stuff by planning it out to within an inch of its life, but I'm just kind of flailing with the design right now. Let's get all that stuff ready to solder. I can't believe all that troubleshooting was just my inability to build at that size. That size of electronics was just evil. Evil, evil. Witchcraft. And it was all down to like little things, and there was like one resistor wasn't quite the right value, and then on top of that there was bad solder joints, and then just everything was so small. It was just a horror show. I'm going to do this, and then it's all going to break apart. Soldering out in the open like this is tough because every single wire is acting like a spring, and if stuff wants to separate, once you hit it with that soldering iron, it will separate. So you got to sacrifice one hand. We were determined it was software. Yeah, I thought the software wasn't working at all. I have a much better understanding of the software now and how it functions, but I really should have gone in and done the equations, because the equations rule all. Now, the equations know what exactly is going on. I didn't believe it. So, all right, we got... Oh, man, I got to keep these 1Ks straight. This is what we're building. Yeah, it was like most of the problems I had were the physical part of it, and it would have been just as simple as all of the tuning guides tell you to tune it. Right? It would have been that simple if I had gone through and see, one of the things was if the latent testing software existed, you know, you could have, I don't know how the STM32 does this. It seems like doing serial prints in STM32 are like pulling teeth out of a skeleton. You need to add all kinds of stuff in order to do serial, but if that existed, you could even have, like, hold down this button, and then it would activate the serial port, and then you could plug it in and just get through UI, like just not even a UI. You could just have it serial print lines and give you values for the different inputs. And doing that is like an initial, like, okay, does this work? would have been very, very useful. And it seems to have existed in the code, but it got pulled out of the code. And so we were kind of flailing and going, maybe it's the code that's wrong. No, it was the physical stuff. It would have been nice to have the diagnostics, though. Hey, Commander M. We're building a totally cool skull speaker out of a real skull speaker. I'm basically simplifying this so that I can leave it on. I can leave it plugged in. So right now, I have wired up the two 1Ks to ground. Oh, I've already messed up. I already messed up. One of the 1Ks does not go to ground, and it's not the one that... Actually, wait, did I already mess up? Hold on a minute. No, because this one has to go to pin 2 as well. So no, I did not mess up, although I did make it a little hard. Make it play scary sounds for Halloween. It used to laugh with the Vincent Price Thriller laugh. Thriller. Ma ha 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 ha. Yeah, it used to do that. Okay, I can improvise here because I put two of the resistors that were next to each other to the ground, and one of them, the one that goes to pin 2, is the feedback. So I've got that set up. I need to get it over to pin 4. That's the one that's the lead that I bent down just a little bit. The other two are, they're like crooked, so it's hard to tell which one goes where. Fartbox V2. No, this is for the modular synth, so that I can just plug in a simple set of computer speakers and listen to what's going on. I could tell you petrol prices for scary sounds. Yeah, that's a whole situation that's going on with that. No, I can't. I can't have it play. That's the whole point of this, is that it's not a digital speaker. It doesn't do that. $1.56 a liter. What does that come out to in America? America units? Now it's an LED. Now it's just a regular diode. Let's see. So, what am I doing? I've got 3 resistors just sitting up here. One of them is already connected to pin 2. That one needs to loop back and connect to pin 4. Let me do the pin 4 hole right now so I don't have to think about it. Pin 4 hole. That's almost $6 a gallon. I don't drive all that much anymore. Most of my operation is right here. I miss having a cool car, though. My Porsche 944 engine swap project never came to fruition because I got too caught up in redoing the computer. And what that led to was me selling the car to a grassroots motorsports challenge team. I don't have a 944 anymore. And I miss it. But that was like in 2005 or something. That was a long time ago. I'm still bitter about it. Nowadays you can't get those things anymore. I wasn't ruining a perfectly good car. A kid in Delaware apparently, and I don't know the validity of his story, but he said he was going down the highway and it just stopped. So that means the engine had grenaded itself. But the damage to the car was consistent with sliding around in a parking lot and hitting the fender against like a light pole. That's sort of what it looked like was happening. That one's pin 5. What does pin 5 do? Pin 5 is 12 volts. Move pin 5 away a little bit. So that's my pin 4 hole. What about pin 3? Pin 3 is ground, so I'm actually going to also need that one to come out. Although making a pin 3 hole so close, and kind of move that away a little bit. Just fan out the pins ever so slightly. Pin 2 is a juncture between a lot of stuff, too. The kid's first fun car? Yeah, it probably was. He sold it to me for about 500 bucks. Heh. Gonna be a lot of melty plastic today. But yeah, it was a perfect candidate because it was burgundy and it had that wavy line check pattern interior, which just made you feel like you were on acid. It's utterly ridiculous. But it was a perfect candidate to go in and swap the motor out. And I put an LS1 in there, and I had it all mechanically mounted. All that was left to do was the computer, and that's where I got caught up. I got caught up trying to use a newer Chevy computer for it, and I should have just bit the bullet and bought a standalone engine kit computer for it, because that would have been the good way to do it, because it would have just been done. It would have been a non-issue, and I would have been driving the car. But I went through all this trouble to do all these different things. I was going to do like an Arduino speedometer thing to try to... Uh-oh, I think I broke the drill bit. Damn it! Not again! No! No, I didn't break the drill bit. It just wasn't done drilling, I guess? Yeah, there we go. Oh, maybe I'm hitting the post. That's what's going on. Did that just get shorter? No. No, 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 no. Yeah, it just bumped into the post. Okay, I didn't break another drill bit. I was like inundated with wiring diagrams all over the place, just trying to, like, I'll do it myself. And that was before Megasquirt was such a big deal. Actually, Megasquirt was a pretty big deal back then anyway, but there are newer versions of Megasquirt now that do much better. And there's also, I think, a whole Arduino engine management project. But I also wanted to do a crossover pipe on the exhaust. And then I was trying to figure out how to DIY. I was looking at those kits where you can measure out the, what do you call it? You can measure out all the exhaust stuff. What are these resistors? It's like a building block kit. I think those might be two 1Ks that I'm not using now. Yeah, I think that's what those are, huh? Because the 1Ks that are up by the skull are these. So what are those two resistors? I think maybe they were to mix audio. Well, those are not going to be used for anything. The ones that I put on the front part of the skull. Volvo. Yeah, my brother's P1800 ES, the wagon version of the 1800, the Saint car. He mega squirted his, and I was talking to one of the I think the facility, like one of the higher ups on the FBI facility that I worked at, and I kept talking about mega squirt in front of the, like, my coworkers were like, you kept saying like something about squirting, and I'm like, it's the name of the engine management. I didn't make it up. Why do these open source projects have to have such embarrassing fucking names? Can't look myself in the mirror and talk to my boss about mega squirting. Yeah, so I mega squirted all over my Volvo. Like, what did you say? What did you say about squirting? Wait a minute. Hold on a minute. Wait. Ridiculous. Did you just say what I think you just said about... all right, so this resistor needs to feed back, and it needs to go into which one? It needs to go into the second one. So the one that's like way back over there. See if we can't get that to loop around. That's our feedback resistor. That's what's doing the unity gain feedback on this thing. Without it, chaos would break out. Of course, nowadays there are ASICs that can do this kind of thing, so you don't really need to mess around with basic op amps. But it's always fun to jump back a few generations in your electronics. I was like, were you just talking about squirting to the director of the FBI's engineering facility? Like, what is this? Okay, and then that's coming up right there. I needed to pick a side. They're doing the leaves outside, so it's like 1,000 hovercrafts have descended. Not really going in there, is it? Oh, yeah, it was. Where was it? Okay, I didn't see it. Mostly, I'm trying to float this circuit inside of the skull's chamber. I don't want to have to add a bunch of extra wires, and I want it to all be solid wires, but these stupid 1% resistor kits all have this very thin wire. I guess lower wattage resistors are cheaper. So now I only have I can't see anything when I'm working on this. It's like, I feel just like I'm blind. A normal bone skull, I would be able to see what I was doing. It's got this cool black plastic all over it, which makes it super, super rad, but also super hard to work on. Where the hell? It's like the wire is poking up. I have confirmation of this. I don't see it. There it is. I want to pull it through so it's taut and it holds the resistor in place. There we are. Where are my pliers? What? Oh, I popped the other end of the resistor off. It wasn't soldered very well. Go figure. All right, all right, all right. Gotta roll with the punches here. Roll with the punches. Oh, it's a little shaky. They don't shake. Okay, there's that. So now I want to bend that flat over this lead, and I can just solder it there and then clip it short. That's going to make our feedback resistor. Weirdo resistors. I need to find a kit like on Amazon of the through-hole resistors that are not eighth watt, quarter watt, I think, but have the meatier leads on them. So they work with breadboard, because currently the ones that I have don't work with breadboarding. They don't make good contact. I don't know. We're gonna find something like that. Should have done the capacitors in front of this thing, because then they could have, oh, whatever. Let's do this. Oh, dog's barking at the people doing the leaves. We'll do that, and then I'm going to solder another lead on there. Basically, I'm working on parts of the circuit as I'm capable of tolerating it. So I kind of break up the tasks and do a little bit of a variety here and there, going from one section to the other. And as I was explaining things and sort of initially assessing where everything was, I was coming up with a plan on what sort of loosely I would like to do with each section of this circuit. And so it's just kind of organically coming together, much unlike a skull. No, wait, much like a skull. Skulls are assembled organically. Wait a minute. They literally have organs. Did you know that your skeleton is wet? I'm trying to tin both ends so it goes on a little easier. Yeah, Weir screwdrivers are the ones that I use. I like them. They're really good. They didn't pay me to say that. Locally sourced organics. Now, a locally sourced organic skull would be larger than this one. So I think this is better. This is nice and compact. This is going to be all crazy, the wiring here. It's just going to be madness. Now, which end, hold on, which end are we starting with? Because I don't want it to be full volume when I turn it on. Take someone's bones out and put them all end to end on the ground, the person would die. I heard that one. I've heard that one. Yeah. Did you know that if you lined up every single brain cell in a human body that they wouldn't survive? All right, let's see. So from turning on, from off to on, I want the highest resistance. That would be this direction. Okay, so this is good. So I'll short these two, and then this one will be the input. And it looks like I'm already lined up to short them. Haha! I've shorted them, like all these people in Wall Street. I'm making financial jokes. All right, so those two like that. I gotta clip that little tiny little bit of end. And the bitter end. All right, there we go. So yeah, this is gonna, it might be very quiet just because of the size of the resistors that I have on the inputs. I gotta be careful about how long I apply heat to the wire, because it will take all that heat and it'll end up getting up to soldering temperature on the other end. There's not a ton of metal between here and there. I hear 10,000 leaf blowers outside. They do this so quickly. It's like we have a yard service for the whole neighborhood, and they come in with like 50 people and just obliterate the leaves, and then they're done in like an afternoon. Of course, there's still lots of leaves. What just happened there? There's still lots of leaves on the trees, so. Well, that soldered itself, and it soldered it underneath the tabs, so I guess I'll just accept that. I guess that's just something we've got to live with now. This is our life. All right, and then that's our audio input, and that goes to one kilo ohm resistor to ground, and then it goes to pin 1 of this thing. So I need a pin 1 hole, and I'll go right in between these two. 1K to ground, and then going to pin 1. I guess I could just, wait a minute. If I do a, yeah, I could just bridge to this resistor right here, because that one goes to ground down here, and then this is pin 1, and I've got a line then coming through that I can then attach to sound in, and then this other one has to go to, it already goes to ground, but it needs to go to pin 2. Who's on pin 2? That's this. And there's a hole there for pin 2 access. All right, yes, perfect. This is all coming together, and I didn't expect it to. Here, let's get the skull on the stand, and I can figure out what the hell I was doing over here. This is, I think these were two 100Ks, and we're not doing 100 kilo ohms on this speaker circuit, so they're just gonna, they might just stay there. All right, let me reach all the way over here and get the stand. There it is. Oh, there's the speaker. You sit down there, Mr. Speaker. But Mr. Speaker, we are for the big. Come on, somebody's got to know it. Star Wars translation, retranslation. There we go. That's easier to work on. The camera keeps looking at the black plastic and thinking that it needs to blow out the white balance. All right, so now I got to get, I guess I could just bend the lead over. Okay. Well, I have little scraps of lead that I could use, but I think I can just coax this lead forward just a little bit. Could have dressed up as Dr. Mario today. That would have been more appropriate for building this thing. I don't have doctor stuff. You know, you usually get the lab coat at the facility and then claim you're a doctor. All right, so there's our pin 1 connection. Pin 1 also goes to the 47 oof. Why isn't this holding this at all? Wait a minute. Hold on a second. I did all that to adjust this thing and get it all in there, and then it just immediately loosens up. There we go. Problem is I need to flip this, and the good place to get the mounts is right behind the glasses, but... Alright, so now that goes to the second one, and then this one goes where? To pin 2. This one goes to pin 2, and this one goes to the... Ugh, this is not... this is not holding it very well. I need you to do better. Hold my skull. I'm going in. Ah, come on. This cheap fucking thing. Come on, buddy. All right, there we go. Oh, I said a swear word. Oh my god. Luckily, aside from now connecting power and ground, this thing is like almost there. And it wasn't that painful to wire up. There we go. I mean, mainly assisted by the fact that this is a very simple circuit. I think the website that we got the circuit from is intentionally making it very, very simple. I melted the seam. That's going to make it hard to put back together. I got to be careful about that. Well, not for long, because I'm almost done assembling this thing. Okay, there's that. And then pin 2 hole is that one right there. You can't see it. You guys can't see anything. try to finish this thing so that chat will finally be able to see what I'm doing, and I'll actually seem a little skillful. Getting the diodes wired is not going to be too easy, because those need to go to... Yeah, those need to go all over the place. That's going to be obnoxious. Well, we'll figure it out in just a second. Oh, the end of it's bent weird. Okay. Gotta, like, fish it into the hole. There we go. Kind of a weird spot, but I guess we can live with that. Actually, that is not the right hole, is it? I don't have any other options, though. I have to make a hole if I need any more. That was the pinhole, right? Yeah, that's the pin for the heatsink. There is one other hole back there, I think. Nope, there isn't. This is the only one. Okay, that's fine then. That's totally fine. We can live with that. I need better pliers to pull on it, though. Better pliers. Make sure that's not colliding with the other one. It needs to be given just a little bit of room. This thing had better work when I turn it on. I've done so many weird things. I have skeletons in my closet. And on my desk. Alright, put those just alongside of one another, and then I'll just drop a bunch of solder on it. The requirements did not say that this had to be pretty. Mark my words. I won't show you this stuff on YouTube. Usually this is just a montage. There we go. Okay. Now I've got that junction. Now, as soon as I put solder on this, watch, everything moves. Everything will break free. All right, everything held. That's nice. Why is that so? Seems like it's been... There we go. Okay. So I've got my connection there to pin 2. Yeah, to pin 2. And that's completes that part of the junction. I think all that's left is for me to do the... Oh, that's doggy cam, and you guys don't see anything. Hold on. Jeez, that was a... There we go. 2 giant address labels right in that camera. Hey, what's up, Passive Crew? Did I miss a... Nope, I saw it. Yeah, okay, so we've done most of this stuff. We don't have a ground connection. We don't have a 12-volt connection. All these junctions need to be worked out. We need to figure out where those are and where those are going to be. Because right now, pin 4 is not connected across the diodes. We've got the diodes individually coming out of pin 3 and pin 4. And then pin 5 is supposed to be power. There's just nothing on that right now. So one of them goes up to power, from pin 4 to power. That would be this one. So actually, I can just do a, just do a little circuity jig on that with a sacrificial pin. Yeah, it's the mind control helmet for the dog. I've wanted to do some of those brain monitoring things, the near-infrared brain monitoring probe. It basically measures activity using the same principles that those, you know, like your smartwatch uses, where it measures what the blood oxygenation and volume is. Does the same thing, but with your skull. And because it goes through bones and guts and stuff and bounces off of blood, you can see the blood volume and how much it's being oxygenated in the frontal lobe of the brain. And the important part is that the brain has this whole structure at the back that divvies up all of the supply of blood. Your brain uses about the same amount of blood at all times, but it will divvy out, it'll expand and contract capillaries in order to control the flow. The dog is thinking. As the one light comes on, burp, dog is thinking. Yes, very interesting. So let's see. One of these is going to ground on pin 3, and the other one needs to go to positive on pin 5. With surface mount parts, this would be so trivial to do. You would just drop 2 diodes just right across the leads, but we're not doing surface mount. Never doing surface mount. Do I want to put a lead outside, or should I drop it into the skull immediately? Probably should drop it into the skull immediately. Neat. Listen, we're not political here, so bye, goodbye. Your comment's annoying. I guess I'm bad at moderating. I can't even get to that. Let's go over here. Let's do that. Okay. So I need to get a ground in there. I think what I'm going to do is just drill a hole for ground. We'll just drill a hole, and I'll keep the wires underneath everything. It's risking my drill bits once again. I've got a lot of viewers today, or in general lately. I don't know. Everybody got busy, I guess. 'Tis the season. October dropped. Everybody's doing stuff, but it is Halloween today, so I assume that people have stuff to do. We don't really get any trick-or-treaters here. So we basically just have a whole thing of candy at the front door. And I ate a Reese's Peanut Butter Cup just as I was taking the doggie out for a walk. And she was absolutely just shocked that I would eat a treat right before we went on our walk. I typically will give her a treat from the jar we keep by the door, one of her treats, and she saw me unwrap this thing and eat it, and I had to get the whole inspection from her in order to make sure that it was okay that I did that. Why is this dropping all the way down? Where's my drill bit? This isn't fair. Hold on, let's get this back over here. Yeah, clearly this is definitely the type of, the comment is just lingering there. Definitely the kind of thing that we talk about typically on this channel. Absolutely, all the time. Literally against the rules. No, she gets one as well at the beginning of the walk. It's just this is the first time that I've had a treat for me. I can't believe you've done this. How could you have done this to me? It's unfair. What? It's still. Oh no, that's where it dropped into the plastic. Okay, I was like, it's still sinking in the holder. How annoying! All right, careful there. Then I put these away so that I don't blow them up. All right, that goes away to where I can no longer harm it. I can no longer hurt it. Okay, our sacrificial resistor has been completely sacrificed, so I'm gonna grab another one. I think I need to organize all of my resistors now because they are just completely in complete chaos. I don't know how many more through-hole things I've got to build. You know, if I decide to make more modular modules, doing the through-hole ones, through-hole is very, very easy to build. You know, I could do a one-day build with through-hole. Of course, I say that the fabled one-day build is never a one-day build. This has been a two-day build, and it's the simplest circuit ever, taking me 10 hours to build. Part of it is that I decided to do it in a cool way, kind of like a cool skull way. We're gonna hot glue those teeth back in when all's said and done. You know, a cool way to do this would have been to do surface mount, but use copper tape. The only problem is this product doesn't exist, and I don't know why. I need, and this has been something that I've been looking for quite some time. This has been like a total struggle. By the way, mahalo, the screwdriver, it's not being shown right now, but holy shit is that thing useful. Holy. Like when I have to take something apart, like the modular synthesizer rack, or like the individual panels, you know, these things have like 55 ins and outs on them, right? And so that auto screwdriver just pops those suckers off so quickly. It's incredible. So thank you. Again, I don't mean to gush, but that was such an awesome thing. Anyway, the product that doesn't exist that I can't find is Captain tape, but with copper on it. Basically the same thing as that orange circuit board stuff, but a tape. I don't see why it wouldn't be outside of the scope of these products to have an insulative layer and high temperature insulative layer under your copper. Most of the copper tapes advertise that they conduct because you use them on like I mean, people use it on like stained glass, but they don't notice that once you apply heat, the adhesive on the backing of it turns into soup. So it's like there has to be just Captain tape, but with a copper layer on the outside. I had the damnedest time finding this, but I think you can buy some stuff from Captain, though. Tape, copper. Copper conductive tapes from Captain Tape, known as EMI shielding tapes. What is Colonel? I'll look that up in just a second. Captain does not give a whole lot of information on what's going on. Colonel Sanders. Oh, you're doing a play on. Yeah, sorry. it's streamer brain affects. Streamer brain is a serious condition involving. I have plenty of Captain tape. You can buy this stuff. Captain tape is wonderful. They use it on the Mars rover as a cable cladding. It's light, it's high temperature. The adhesive stays adhesived over a large range of temperatures, including soldering temperature, which is why I want Captain tape with copper on the front, so that I can use it as like an adhesive circuit element. Because that would be cool to do on the skull, is take a blade and cut your circuit and have it on the surface of the skull. Do like a much more complicated but one layer circuit, and then like put a bunch of this stuff on the skull and then cut it with a blade to make the PCB. That would be really cool to do. And then you could use a surface mount. You just couldn't solder it for very long because it would melt the plastic underneath. But if you do it with regular copper tape, the kind of copper tape that you can just buy anywhere, the copper tape adhesive becomes soup. It just completely liquefies. So you can do it, you know, that's not that hard to do. You could do that and then cut it out and then solder it. It's just you got to be real quick soldering it because that stuff just gives up. Building ground systems, static charge chaining, cable wrapping, surface contact, non-solderable. Surface contact to non-solderable material and point-to-point electrical contact. In addition, they're known to act as excellent barrier to slug and snails for entering into protected areas. Problem is, we just don't know what's on the backing of this stuff. It's also probably pretty expensive. All right, well, anyway, that's just something that I've been looking for, is copper-cladded Kapton tape. Kapton. How do you guys say it? K-Apton or something? Some weird fucking Euro-y way to say shit you always do? All right, so the part that I've been avoiding, and I guess I gotta solder this thing right here. Let's do that so that I have a pin 5 output into my circuit area. But yeah, doing this the artisanal way and finding like a one-layer circuit board would have been really cool. That would have been a really unique thing. But I want the speaker, right? I don't want the project. So we're getting it done. Getting it done with this simple audio amplifier. I wanted to do one of those copper-clad, you know, like coffee table or something like that with LEDs all over it. Oh, that's really terrible. I don't like that at all. Hold on a minute. I gotta put this on my belly. I know that feel. Yeah, it's like it's one of the few instances where I need the thing. It's like burn the subs. Like I need burn the subs. I don't need the project right now. I'm having a lot of fun doing the modular synthesizer stuff. Is this turned itself off? My soldering iron seems to think that it is a cigarette in bed and needs to be turned off before it hits anything. Maybe next year. Maybe next year I'll get another skull speaker and we can do the same thing to it. Or maybe I'll get one of the skulls of my chat members. Maybe that'll do. All right, this is pissing me off. Hold on. Yeah, that's literally what it does. It goes to a standby temperature, and then it'll auto turn itself off, which is good because I leave it plugged in and on a lot of the time, just because it has that feature. I'm able to do that, but it does it while you're soldering sometimes, which is obnoxious. No, it's like the problem is it's a good feature. Also, how would I solder it? How would I? What if removing that feature involved soldering? What do I do then? How's that supposed to work, huh? You didn't think. You didn't think. You didn't think, and now we're here. That's a really bad job of soldering. Oh my god. I'm gonna get the other end attached and then I'll re-solder it. Because yeah, this line needs to go to which one? The previous pin is that. Pin 3 is ground, and so those are ground, and then pin 3 I'm gonna have to get to ground. Where is pin 3? Does pin 3 come down into here? 1, 2, 3. There's nothing attached to pin 3, so I'm gonna have to make a ground for that. And then one of those goes to one of the diodes, and then the other diode goes to power. And the power one is the one that's on pin 4, which is there. Pin 4 is... So that one goes to... Wait, no. One of them goes to pin 5. One of the butts of them goes to pin 5. Is one of these backwards? No. That one goes to ground. This one goes to power. That's our output. That goes... This goes... Disco. Oh my god. Okay. I'm trying to figure out what I did. If one of these diodes is in backwards, I don't think it is, but oh, hold on. So on pin 4, I should have 2 ends of diode. And I have a resistor on pin 4. 1, 2, 3, 4. There's a pin there that goes to a resistor. Oh yeah, that's the feedback resistor. So that goes to, oh, it looks like I could just bend this over. Monsieur Dover. Wait, no, I can't. Overdosed on water. Hello, drowning victim. How y'all doing today? Okay, so 2 diodes. I'm trying to, hold on, let me think through this a little bit here. The junction of pin 4 needs to go to the pin 3 diode here. Junction of pin 4 is right there, and this is the end of the pin 3 diode. So all I need to do is bend this over like that, and just cross it. I know that you can't see what's going on in here. I'll show that in just a second. And then the other one goes to power, and the line end goes to power. Power is also pin 5, which is this line right here. So if I can get that, well, there's a post in the way. Dun, dun, dun. I think I can bend that up and around the post, and then first past the post. This thing's chin gets in the way when I want to tilt it to work on it. Here we go. Let me get some... Oh, that's the microscope. We don't need that right now. We don't need that right now. We need this. I need to focus on my cool skull speaker. There's something fun about Twitch where you have these weird accounts that have agendas that come into your chat. They're like bots, but they always have something weird and interesting to say. Like OctoJ was always like, I can like ban those things ahead of time, and I'm like, no, they got a little bit of charm to them. They're kind of quaint. Like, oh, that was cute, and then you fucking explode them. It wouldn't be Twitch without them. I always love the viewer bots, but those have kind of gone away. All right, so power will be here, and maybe I'll attach the wires over here too, just directly to these diodes. I am going to have to drill a hole probably up here for output. We'll have to grab our output and ground from this area. This is kind of sloppy, the building of this circuit, but I don't know, I'm having fun. It would be my idea for putting it down in copper tape and then cutting it out. I like that idea a lot better than this, because it would make kind of a cool pattern on the skull. But then I would need to design a 1-layer PCB audio amplifier that uses surface mount parts. I've got plenty of op amps. This is not staying in the... Please, just stay there. I need to be able to solder to this junction, so I need these to naturally just kind of stick together. There. Now they're naturally stuck together. Now I'm going to unnaturally stick them together with solder. No, this is for the synth. I'm not going to make the skull fart. If anything, I'll make the Furby fart. That is the plan with the Furby, is to make that the fart noise maker, and then we do a little bit of puppeteering with it too, and make it kind of like wiggle around when it farts. The Furby is a much smarter device than that, though. So it is a little bit demeaning, but hook it up to AI and make it like talk. Hello. It would be kind of interesting to have it hooked up to like a chatbot AI, and I could then have conversations with, but I'm not going to really do that. I'm not going to do that. I got to get in here without melting the plastic. I mean, I guess the design of this thing is, it can be melted. That would kind of add charm, but the long Furby, yeah. Furby could move and react to chat. Are there AIs that do moods? Just have it like throw chat into an AI, and then the Furby would display the mood based on animations that we set. I haven't looked into the Furby. I've had it for a year or two now, and it's just been sort of on the shelf. But it was supposed to be part of, you know, creepy stuff that I can animate and control, possibly with Node-RED. I don't know. I don't know if I'd hook it up to Node-RED or not. I do kind of want Node-RED to be sort of the front page in terms of interactivity of this stream. Yeah, they just take other people's moods. True. True, true. All right, let's see. So these wires are useless. Let's get those out of there. Oh no, these are the sunglasses. That's right. That's right. These are the lights behind the sunglasses. That's what these were. I remember now. So those need to go to ground, and then probably take them from here. And then this needs to go to power. And I don't know which leg of that it's going to be power. Okay, what's next? Let's see. We've got this one going to positive. So that needs to go to the thing that I just soldered. How's that going to get there? That's a long trip. It needs to go to here. Typically, I'd go over here, but that post is right in the way, so maybe I just go above everybody. Just like that. And then I need another piece right there. So where did my wire go? I had a sacrificial resistor that I was using. Here it is. Lights in parallel with the speaker. Ah, no. I don't want, see, okay, I want an indicator that the skull speaker is powered. If I'm going to put status LEDs of like audio signals, I should have them sticking out of the top of the skull. I just don't know if I can just put an LED across the speaker and have it still work properly. I don't think it works like that. But I did want to do something like that. I feel like it would actually take a little bit of designing. I think I need an op amp to do that. All right, so we'll do the height of the tweezers. Dog is wooing at the door. Woo, 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 woo. Ah, this junction is going to be not having a good time. No, I've already got status LEDs as in power LEDs in the eyes. There was a mount for them and everything. Although it would, you know, one thing I could have done is taken this stuff off of the glasses. Those are actually, this is screwed in right now, so I can't show it. Taken the grating off of the glasses and used each one of the holes as an LED hole. And I could have had like a screen, but there are red LEDs and they light up sort of the center chamber, which will show in the grid pattern, the grid pattern of the glasses. So yes, I already done something with LEDs. That's what those two resistors are. I forgot about it. There you go. And it's literally just power is on light. That's all it's going to be, because I need to know that this thing is powered. That's the thick of it. I need my heat sink to solder on top of, because I don't want to. Vinyl wrapping a mirror cap is a royal pain. Are you using soap and a credit card or something? Isn't that the way you're supposed to do vinyl wrap? This will just be so I can pre-tin both sides of this line. Why is that song still stuck in my head? I keep getting these dumb songs stuck in my head. You're doing it dry. Yeah, that sounds like you'll want it. I mean, the liquid's not that bad. Because it gives you the opportunity to work the adhesive. You can work all the wrinkles out of the adhesive. All right, so this isn't going to want to stay on my tweezers properly, but I need this to connect with the junction down there, and it's not in an easy to get to spot by any means. Even harder for me to film myself doing this. I can do that. And then you need to wait a little longer than you think because the solder will stay liquid for too long. All right, that's a big cursed junction, and I can smell burning plastic. What did I hit? Ah! Oh! My skull! Oh, no! Okay, let's get this back up on here. Maybe tonight. Oh, my brain won't let that song go. Let it go. Let it die. It's had its time. Yeah, this is a big disorganized circuit, and I never wanted anything else from it. A later iteration, at a later time, we can do the more fancy stuff of doing status LEDs and things like that. And my, tape circuit would be great. That would be really great to do. I'd really love to do that. But right now, I just want to get this done. Just want to get this done. I want to wire up this barely functioning mess and get away with it. So that's power, power, power. Oh, I need to do that ground right there. That's tough to do. Or no, that's our speaker output, actually. Okay, so that's down against the bottom plastic. So it's going to melt it a little bit when I do solder it. How do I get to it? How do I get to it? It's all the way back there. Oh, boy. That didn't do anything. I think I just put a bunch of solder on the iron and nothing happened. Oh, and I melted a bunch on the top of the iron. Darn. Ah! No! Stop doing that! Jerk. It looks like I soldered it, I guess. Try to do it again. Yeah, it's soldered. Okay. Oh, man, this is stinky. So I've got my pin 5 output. Yeah, now I can fix that. I can fix that. It's a little sloppy. I think I should just add a bunch of solder to it, and that'll make it look smooth. Just paste over the whole thing. Forget anything ever happened. All right, so I think all of the connections that need to be made have been made, except for power and ground, and then I need to do audio as well. So these LEDs go there, these go to ground, and then this goes to power. I don't know which one of these is going to be power. So let's take a look at that. Some cloth. I don't have anything like that, no. Yeah, this is silly. That's all right. We can just struggle with it for a little longer. It's just this, this thing is for holding circuit boards, not skulls. So it's a little bit outside of its purview. And it is just a piece of plastic, so... okay, blah, 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 blah. What am I doing? I'm multimetering this thing so I can figure out where power and ground are. Ground are of the hill, people. All right, ohms. And I'm assuming that this is common, and then these are the normally open or normally closed. So that's normally closed. That's normally open. Click. And now it's closed. Okay, so that means that our... Which direction are we going in? I could use this tab, or I could use this tab. I'll use the back tab to do the internals. So I'll go right over to there, and then we'll do like a wire over to this part of the circuit. It needs to go to here, and then ground needs to go to here. Ground will just come over from another part of the circuit, from the other half of the skull, which means that this needs to go to this giant junction. Oh boy. And then I'll probably have to use hot glue to hold everything down. Looks like the LEDs were the most annoying thing to wire of anything else in here. Is there an easier ground than that? I guess that bar is pretty easy to hit with a bunch of wires. Yeah, we'll just do that. Okay. What is that from? Ah! What is... I guess I need to use the 0.6 instead of the 0.8. It's always kind of annoying to work with this wire. All right, give it a little twist. Give this a little twist. Tin the lines, and then I'll just solder them directly down to the circuit board. We'll power this thing on and then see what explodes. You know how it is. Hopefully it doesn't explode, but I mean, I've not tested this circuit. I didn't have it in the breadboard. Probably would have been a good idea to put it on the prototyping board first. All right, these two will go here. Sneak them under this positive bar. And then I'll just do, let me tin this. And then that bar will be our distributed ground directly off the capacitor. Gonna be plastic smell for all of these. Delicious plastic smell. Very good. Where are my tweezers? What did you do with them? Why did you hide them from me? Here. You've turned them against me. You've done that yourself. That's one. No, I didn't hold it there long enough. I hate it when that happens. When you solder something that has a lot of heat capacity and you remove the item too quickly and they just fall apart. One of the more frustrating things. Where's this one? Oh, there it is. Hard to see what I'm doing. Hey, here you go. Is it soldered? I guess it is. All right. There's our LEDs wired up to ground. And then we'll have another wire coming off of that one. And a wire coming off of this one, which is in a weird spot, but it's all attached properly. And then that will power and ground our circuit. Power, though, is coming from over here. So now I'm going to make a big, obnoxious, solid wire that goes for as long as it can to get to the pin. Where is it? Actually, it'll come from here, and there's two locations to go to. So that one can get a bridge, and then this one's longer than the resistor. So I don't know if I can make a proper bridge of that. I could use the solid stranded... No, that's not going to carry all the current of the speaker. Let's see here. Well, let me get a sacrificial... What happened to my sacrificial resistors? I keep sacrificing them. All right. So grab another one of the very popular resistors here that I've had to reorder. Yeah, I can't do that with one piece. So I'll do it with a wire. It'll be the shakiest wire ever, though. Just floating out there. I don't like that. I don't know. Well, if I do this on the top piece, no, I still can't make it over there. Yeah. I wanted power to go in here, although I could do it there. It doesn't really matter. No easy solution here, I guess. Unless I had taken this over this way, and then I had a bunch of stuff there, then I could have gone. That's okay. So, what am I going to use? Use a random piece of wire that I found. 1 ohm resistors. I don't think this kit has 0 ohm in it, actually. Might. Not a bad idea. Let's just see. They would be all the way down here. Now, it starts at, oh, 1 ohm. This would be if you wanted to measure across this. How many watts is this going to be? Because the 1 ohm resistor might not be able to handle all the watts. But yeah, a 1 ohm resistor would do it just fine. Just fine. Just means I can measure current on this if I need to. Actually, I should probably put it down here, like this. Yeah, we'll do it down like that, and then I can go over to that junction. Oh, I could actually cross everything. Wait a sec. The solutions, they're sparkling. What do you think about the people of Russia? What the fuck? Who programs that? Lots on Twitch, I'll tell you something. Why is that not soldering? Ooh, that came with old electronics smell. That smells like the old Radio Shack smell. That's something I haven't, man, that's a wave of nostalgia right there. I don't know if you guys know that smell, the Radio Shack smell. Like when you're working on old stuff, you get a wave of that stuff. I don't know what specific smell it really is. It's like asbestos and cardboard or something, but it's a thing in electronics. That's that good stuff. I need to prime this as well. Yeah, wave of nostalgia and just a few lung cells that don't stop replicating. One ohm resistor idea. The dumbest idea I've ever... Okay, I'm doing it. Yeah, okay. So we'll just get that a little closer. And then we'll just tap off of this one. I could do it like that, actually. Yeah, we'll do it like that. I miss Radio Shack. You know, they would always start out so good, and then eventually all the electronic stuff would be so disorganized. And I'd always do the Nick Offerman, like the guy comes over to help, and you're just like, I know more than you. Like, I don't need you. I'm looking for, do you have triacs? And he's like, I'm like, yeah, just leave me alone. It was like $5 for an LED. Like, I don't know. Micro Center is much better with their electronics section. They got all the Arduino stuff. Twitch chat is smart. They are. Twitch chat can be surprisingly smart, actually. Like when I was coding, you guys just like know it all. In kind of a know-it-all kind of sense. You know it all, you know it alls. You guys are a bunch of obnoxious fucking... I mean, you know everything, yeah. There. That's our power hookup. And it's actually disastrously close to that other pin. I don't know, I could put something on that pin, or I could just trust that the resistor won't bridge contact. Oh, I used to go to the Richmond, Virginia Micro Center. That one's pretty good, but it was kind of far away. But yeah, I am near the St. David's Micro Center now. That's what we got. Even that's a little bit further away from me. So ground is on that bar. Power here. Audio here. And I guess the speaker output, where's that? That's on the junction between the two diodes. I need to make a hole for that. I'm going to make a lead for output. I could do a JST, an internal JST with the two pins sticking up. And then get, what, ground? Which one is, pin 3 is ground. Get ground over here, and then output over here. This is going to be tough, actually. This is going to be tough to do, but I'm going to drill in here and put a JST internal. We actually call it micro mecha. Yeah, we do. Best I can do is buy within reasonable distance, so it's Amazon. Yeah. It's an unfortunate reality that, you know, even though Amazon is kind of dwindling the amount of good stuff you get from their service, it still is incredibly worthwhile. I'm sitting here on an Amazon affiliate platform telling you guys that. I mean, YouTube Premium is... YouTubers, hey, I have no viewers over there. There's nobody watching. Nobody's watching. It's there purely for archive purposes. It's funny. I'm starting to wonder about what I've said about the discoverability of... Oh, wait, I gotta go over here for this. Maybe I just do it with wires? Well, if I drop both of them down, maybe I can... That's kind of a tough thing. It's kind of tough to solder. If I put it over here, then I don't want to run... I don't want to run my circuit connections along the surface of this thing, because that would be liable to be brushed up against and disturbed. Like if I brush that, I don't want it to like reconfigure my circuit. This, you know, obviously going back in and redoing it with copper tape and very carefully cutting out a specific pattern would be awesome to do. We're not doing that here, and it would certainly organize things, and that would be running wires along the surface, which I want to avoid. What does the back look like? Yeah, the posts get bigger. This should fit together still, although I probably have to clean up some of the burn marks. And this thing has a JST on it. Yeah, every time I go to a Micro Center, I'm like, I have to buy something or I'll feel bad. Oh, this doesn't, it's not a JST. That's a different one. It's a slightly higher pin pitch. Would these pins fit inside of a JST? They might. I don't need to preserve the plug. I guess that's not total priority, but it would be good to get a ground and output signal wire. I guess I can do them. I can still do what I was going to do and put them both here. So I can get ground and output right there, and then that'll be easier for me to solder to. And then all we need to do is run power and ground, and I think we're golden. What a weird circuit. That 1 ohm resistor thing was ridiculous. That thing's going to get kind of warm, I think. We could measure current across it. It's a very accurate 1 ohm resistor. Should be 0, but if we need to short it, I can short it. Yeah, living close to a Micro Center is like it's like a priority. Oh, the drill bits. That's what I'm waffling around, not doing what I'm supposed to do. Let's get this over here. Hopefully those resistors that I put in the path, the 2K and the 6K are enough, or aren't too much, that I don't get an audio signal. It's supposed to have a 1K, but if it's stereo audio, I'm taking each channel at half into my mono speaker. That would be a thing to do with the skulls. I could do two flat circuits on each hemisphere of the skull. I don't know the biological terminology. 2 flat circuits on each I don't know, lobe, and then no, that's not lobe, whatever. And then have it be a stereo speaker somehow. I don't know how I'd do that. If I bought the exact same one, I guess I could get smaller Harman Kardon speakers. Yeah, let's do the output here. So I need 2 holes. I need them to be a little bit far apart, and I need them to not hit that post. It looks like they are going to be behind the post a little bit, but that would be the whole purpose of adding the wires, is that it'll make me able to operate around that post, I guess. I don't know. Here they come. I hear 1,000 leaf blowers on the horizon. What's going on here? I don't want this to immediately snap the drill bit when I get through. One errant twitch. And kablooey. Okay, there, I'm through. That's one. And I guess I can get ground from inside. I can go to that same bar. Or I can do it... Nah, I'll do it right after the amp. We'll just split it off and have another ground over here. No, I don't need to do that. We'll do 1 hole. What am I thinking? What the hell's going on there? How many Canadian farts can this Twitch handle? All right, let's do this. And then creatively bend it. Oh, best I can do is best by. Oh, I didn't catch that. I wasn't reading properly. All right, so right about here. Then that, and then that's going to be our output line. Nice 90 degree. How do I get this on here? Wait a minute. How does it, wait a minute. How does this, hold on. Getting this on here without it going, okay, what? I bend it like all the way and then unbend it, just like that. There we go. Yeah, it's just going to be a mess of wires inside. I can't control, oh my God. Thank you for that cheesy popcorn. That actually scared me. Actually afraid of my own fart box. There we go. Now if I can just drop a ton of solder just right in there. All right, down here. The fart box is something that exists in the physical world. It is not just a piece of software making a fart noise. So when you hear it, you're going to hear it through my audio. You're also going to hear a lot of leaf blowers through my audio, because about 15 guys have now descended on the little alleyway that is between houses that I live in, and that's where my tent is. And they are going to leaf blow the ever-loving shit out of those leaves. They're going to get them all out of here. So it's about to become chaos. You're going to hear it buzzing behind my voice. How am I going to solder that? All right, hold on. I'm going to lift it up a little bit off of the base, off of the plastic. Ah, damn it. Dang it. This is where I need 3 hands. My God. All the yard work is more exciting than what I'm doing. That should be in position if I'm just careful. Let's see if I can maneuver myself in here somehow. Could use the little tiny tip, but this works decently. I guess that's soldered. That's our output. Wait. Pin 3 is ground. Pin 5 is power. Yeah, pin 4 is output. 1, 2, 3, 4. Okay, good. We're on the right pin. Getting a little concerned there. All right, so that's soldered. That's our output. I mowed my lawn yesterday. This is far more entertaining. I don't know. There's something like zen about doing that yard work. Maybe it's just my age talking, my impending fucking birthday, to where I am now the age that basically is an old man on the internet. There aren't supposed to be people my age on the internet. We were there when the fucking thing was invented. I used to use an Apple II. Get off my lawn! All right, ground, power, speaker, output. Those are our 3 lines. Oh, and input. Input, ground, power. Input, power, ground, speaker, out. Yeah, it's an excuse to listen to music, you know? All my friends are like, listen to a podcast. I'm like, no, I don't need mind poison. Oh my God, there's so much hullabaloo going on. All right, let's get lines soldered to stuff. Oh, I can get this out of here. Oh my God! I'm about to get, like, drowned in 2-stroke exhaust, aren't I? I guess you guys can't see anything going on out there, but there are people out there. Oh my God, oh my God, oh God! You got a chainsaw! Oh, dear God. Uh-huh. Well, there goes my ability to... Yeah, you probably should hear it. As you can see, all my stuff get blown around. It's still going. Yeah, it's keying my mic. It's even clipping. Oh my God. I smell nothing but 2-stroke fuel. All right, they're starting to head away. Asthma. Leaf blower asthma. Suburban noise damage. All right. Quieting down now. You still hear it though. 'Tis the season. Wow, that is not very on there. That is barely attached. You cut back in, they started up another. Yeah, I'm not gonna win this. This is not winnable. Tonight. I may need to do new wires on these because these are like about to break. What? Oh, I changed scenes by accident. I hit the mouse. I have F-22s fly over my house daily, so not that bothersome. Well, it's a lot of white noise. I just hate the ramping up and down of the leaf blowers. Yeah, look at that. It's an embarrassment of riches because I'm not the one having to blow leaves, so I'm happy that there are people to do that. But, everything after but. Oh man, it is smoky in here now. I hope this filters out quickly. See, the thing is, all those leaf blowers are in the alleyway, and the alleyway is where I get my oxygen from. That's where the air for this room comes from. So with all of those two-stroke motors in that alleyway, I'm like getting smoked out. I'm gonna get lung damage. Oh, now the dog's going crazy. She is not afraid of leaf blowers, actually. I was cleaning up the driveway and leaf blowing my car, because if you have a car that's an outdoor car, you've made an indoor car into an outdoor car, you need to make sure that all those drains are clear. They use F-22s as leaf blowers? Yeah, the vectored thrust really helps them get into stuff. Yeah, if you have an outdoor car, you got to make sure that all the vents are clean. All the structures that are designed for water to get through, basically. And so I had to go out there with a leaf blower and make sure that all that stuff was nice and clear. And the dog was not afraid of it at all. Now, the vacuum cleaner is public enemy number one. That vacuum cleaner is not to be trusted. She will bark her head off at the vacuum cleaner. But leaf blower, no problem. Sunroof drains to your passenger floor. Yep. And there are tubes in the car, but some of the tubes are at the base of a basin. And if you let those fill up with water, because all the debris gets in there, clogs the drain, and then it's this big liquid basin. Fills up with liquid. My brake booster had a pile of rust come out of it that was this tall. Made a pile of rust. I've never seen anything like it. All right, let's see if we can get this thing dooting. We should be able to hear doots soon. Doot, 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 doot. Oh man, it is stinky in here now. That's a bouquet of smells that I'm getting. This is why we don't buy cars with sunroofs. That's because, no, it's because you guys are all mutants and you're like 8 feet tall. And so you don't fit into normal cars. Like the rest of us who fit into normal cars, because I'm the most average person in the world. All my friends are giant mutants, so they hate sunroofs. And car guys generally hate sunroofs because they are a flexing thing, much more rigid without one. And light. People kind of forgot about lightness in cars. Yeah, because race car. I like having a sunroof, damn it. Everybody else hates them. A friend who went through great lengths on his M3 to put a carbon fiber roof without a sunroof on it. Because he's a giant mutant. So tall, I have to measure myself in meters. What are you metering? Have one, and I never use it. I rarely use mine, but if it's like a summer night, it's really cool to have one. You can't take that away from me. All right, so I guess we're just gonna permanently solder the halves. That'll be fine. I need power wires, and I need to be huge. What am I going to use? Not any of the stuff that I have in front of me, that's for sure. Not this random piece of wire. Gluing on a roof cap is an awful job. Yeah, I think he had somebody else do it instead of doing it himself. I don't think he would be trusted with a Sawzall to get rid of the roof in a clean enough manner to have the new thing. And then, like, who's guaranteeing that that thing is a rigid structure in a crash? I guess he made sure it was done right, because he's got nothing but budget, but... Oh, really? You did a couple Range Rover bonnets? They have soft spots. Oh my god. Sunroof and Nerf gun. There you go. Now you're thinking. Now you're thinking. Just need to drill out rivets? I think... I kind of remember him doing that. He did a bunch of carbon fiber stuff on his M3. Which is weird because, like, you've done all this weight savings, but you're this giant mutant. You're just like 6 foot tall weirdo. 6'2"? 6 foot... I think he's 6'1" or something. Giant mutants. Anyway, where's our audio? That would be this line, right? This big mess right here. And so I need 3 wires, and I don't want to use the 22 gauge stuff. I want slightly larger wire. Where am I going to get that? Well, I don't really collect that kind of stuff, really. I guess I can cut up a couple of these leads. Seems like kind of a waste, but those leads aren't expensive, so these aren't that expensive. And they're the kind of cheap crap wire that I would like to use here. That'll do. Well, power and ground, too. No, you know what? No. I'm going to find... I got a whole bin full of derelict wire at my feet. And I'm going to use it. This kick panel of wire. All right, what do we got? This thing. Yeah, that'll do. Bada bing. Yeah, I have those, and there's a variety of different like hookup wires that I use with the perforated prototyping board when we're reverse engineering stuff and whatnot. All right, this is the thing. Everybody, you do a little bit of electronics, and suddenly, damn it, it's not coming off. Suddenly, everybody's e-waste ends up on your doorstep. Man, I am inundated with that smoke, huh? Should probably do these a little longer. I don't really need... No, I don't really need to. I'd like this thing to sit next to itself when it's... Yeah, it does look like I have to do a little longer. Because that needs to go there, and then this one needs to go to the other one. Well, maybe I could do it like this. Yeah, that'll do. Okay, we'll do it like that. That way I don't need too long of wire. This is obnoxious. We'll do the blade method. Always away from you. Come on. Okay. Go to knife. That was one of the first clippable moments on stream. Is I had a little remote control car tank, little miniature RC tank. Those things are really cool because they have rubber treads and everything. And I took the RC tank and I hooked it up to an ESP8266 that was monitoring chat for keywords. We had a set. That was back when Twitch had multiple chat rooms for your streams, and so we made one of the multiple chat rooms into the tank controlling chat room, and it was able to scoot around on the desk. And that was about when Roboz was playing Cooking Simulator, that Cooking Simulator game. And I think he had like a rage quit or something. And so he raided into my channel, and so I had about 1,000 people controlling a little tiny tank that would take commands. And to amp it up a little bit, to make it a little bit more tense, I taped an X-Acto knife to the top of the tank. And so chat was actively trying to stab me with this frickin' thing. It's still, the footage is still on Twitch. On my clips section, deep somewhere in the clips section. All right, what's happening here? Come on. Wire's not cooperating. All right, so power and ground. Power is going to be on the pin. Ground is on the not pin. There's like bits of old wire on this. That's right, we're not really going for clean here. This whole thing is just a very sloppy project for fun. I decided to do something easy for my inaugural Twitch co-streaming. Okay, I got rid of that. There's going to be something tragically wrong with this, isn't there? You just know it. Something I didn't wire up correctly, or something will pop. It's that kind of project, you know? It's just that kind of project. Yeah, I'm going to get the speaker wires, or I can desolder them from here. I can also resolder them from here. That'll be a little bit more difficult, but shouldn't be too crazy. All right, so those are out because they're too short. Too short. And then these are power. Bring everything right here. I know it's not good to wire everything together, to bundle everything together, especially in a system like this, but I'm going to do it anyway because this is a very stupid computer speaker. It's not that special. It's really not that special. Probably should have done the yellow line as power. That's all right. So we need I need that ground to go to this ground. So that's going to be a short piece of wire on that. And then I need audio. What else? Power, ground, audio. Oh yeah, speaker. Actually, I can do ground to ground to ground. Yeah, we can do that. Okay. So I'm going to take this wire and make it all my internal grounds. It's guaranteed something not working. Those mutable instruments modules were such a struggle. I'm nettled. I'm nettled about it. I'm super nettled. They were such a struggle to get everything to work that it's been like a confidence hit. That's where this comes in. I didn't imagine I would have to go all the way down to equations in order to figure out what was wrong with the mutables module. It's crazy to me. Oh, let me get the speaker output wire soldered first, because otherwise I'm going to crush that wire. So speaker out is going to go... It's going to go to green. That will be greened. Yeah, it feels like I should have been building those things like bit by bit, like section by section, and then finally at the very end dropping the chip in, because the chip is the most sensitive part. That's the $12 part. Oh, what kind of a freaking nerd does math? But what I did is I calculated how that op-amp section was working, and I got 1.6 volts due to the ratios and the -10 reference. And then looking at the voltages on the board itself, I was able to measure 1.6 out of most of the outputs, and a couple of them were not doing well. So I had to then go in and check all of the different components, and it turned out, on one of them at least, it was a bad chip. The chip had actually gone bad. In compiling GCC on a C-lang for RISC-V, what is the ratio to real words versus connecting words in that sentence? Switching back and forth for like a week, so now I know the pain of the software side. Oh my god. Yeah, none of the problems with the mutables were software, believe it or not. Although software could have really helped. Because software could have helped us figure out what the heck was going on with the circuit. All right, there's... Nope, damn it. Yeah, the old IRC way to correct. Would you cool off already? Jeez, okay. The big puddle of solder, so it doesn't like to cool off. Okay, so I'm going to go ground to ground to ground, and then the wire, this wire will be the output wire, but I'm going to need another connection on that. So I'll desolder this. I said I'll desolder, there we go. Desolder that. I'll bring this in. Aren't there some clients that automatically do that kind of correcting? I'm glad Discord has the feature because I use it a lot. I always typo everything, especially when you're not paying attention and, okay, the hovercrafts are back. Apparently this is lap 2 of the circuit. I can fix him. All right. Man, some of these components let off that old-timey solder smell. Heavily leaded solder and whatever kind of insulative cardboard they use. All the asbestos. Very nostalgic. There was some big upset with the hovercraft racers lately, and I guess something about the regionals. So they're training pretty hard right now. A lot of buzzing. Soldering 2 wires to 1 post is an ancient and forgotten art, and I hate it. I hate everything about it. You know, back behind here, along with this one. The jawbone is wired to the fusiphone, sousaphone. The wire bone's connected to the electricity bone. All right, there's that. Get this one tinned. That barely looks wired, but I guess it's okay. Yeah, I get that. Those wonderful fumes. Mm-hmm. And now we need a speaker wire. I'll make it purple. Oh no, I just need another ground wire. Okay. Well, it's in, out, ground, and power. So we have ground power in. No, ground power out, and we need in. Okay. So I still need an in wire. I'll make that purple. Make it purple. If I really wanted to be old school with this, I would find whatever that wrapping paper is that they wrap wires in and do a loose spiral around these. I could use spiral wrap on this, although it seems like kind of out of place for this. Whereas I can just hit it with like a dollop of hot glue. God, this is such rudimentary soldering compared to all the high-tech surface mount crap that I've been doing lately. All right, now I just need from here to here. It's this thing. So what we have is we have a TDA 2030 amplifier set up in a non-inverting unity gain configuration, and then I have resistors that are doing the summing of left-right as well as the attenuation for a Eurorack level of voltage. I could make that more complicated. I could actually do buffer amplifiers on it, but I wanted to do just the simplest. Just the simplest. I'm missing this. It's not tinning properly. Would you please tin? Jeez. That was like a huge struggle. Oh man, I should get that. Yeah. Black hot glue is Didn't I order some? Wait a minute. I think I ordered some and it never arrived. Because, yeah, I remember we were talking about that, I think, Gonad. I wanted to get some of that stuff because it would be really good for putting things together. I don't like the translucent, you know, jizz assembly that hot glue normally brings to the table. It's not as sticky as the normal stuff. Ow. Why has it gotta look like jizz? Man, YouTube's gonna come in here and like punch me in the face for cursing. Maybe the buzz will help mask it a little bit. Yeah, the normal stuff, like I don't know if I really need it to be. Well, I don't know. Sometimes the normal stuff is too sticky. Not often, though. I wonder if this wire is, like, corroded, and that's why it's not cooperating. Or if I just can't see because I'm too far away. The brave little tank only lasted an hour? Oh, didn't it, like, it threw itself off of the table. There were other times that I got it running, though. All right, the world's worst soldering job is almost over. So, in speaker, power, ground. And then I guess I'm gonna get a little bit of spiral wrap and just put a small length around one part of this just to hold it. Because I'm not gonna use the full length of these. These will go basically just like that. Of course, they'll rattle around all over the place. There was a sign, don't drive off the table. Well, I mean, the best is when it stabbed the tape reel, because it seemed to have punctured the tape reel, but it didn't have the inertia to actually do any puncturing on me, because those little treads couldn't grip the desk surface, so it bopped up against my finger, and everybody went, oh my God, and it actually didn't do anything. It was very dramatic, very dramatic. I gotta move stuff around here. We scooched everything off of the table because Julian and Dave were here with all their synthesizer stuff. But now they're not. Now they're not. Dun, dun, dun. All right, random piece of spiral wrap. Ooh, my butt, my butt. These stools are from like the 1960s, 50s, maybe even older than that. They're not incredibly comfortable. They are historic, though. This is going to be too big of a piece. Let's just do like that. And then it'll rattle around inside and I'll hear it. This isn't really professional electronics design. This is just supposed to be a silly thing that will allow me to listen to the synthesizer. This is the skull of that guy from the Powder That Makes You Say Real meme. He's got the sunglasses and everything still. Gaming chair sponsorship. I hate those things. Oh man. Oh man, do I hate those things. The basically failed racing seat companies that didn't get anything like certified for crashworthiness or anything like that. And so they just pivot and decide to, oh, we're a gaming chair company now. Let's make gaming chairs. And so you get these failed car design chairs that are designed to keep you in your seat when maneuvering, not designed to be ergonomic in any way. No, they would be incredibly unsafe in a car. I mean, we're not talking about the best of the best here, you know? Actually don't need much more length than this. Where are my hookups again? Oh, the speaker out's got to go all the way over to here, which it already does. And then audio, and then ground needs to go to there. So here, oops. That one's full length, and then this one goes to there. God, water-flavored song. They didn't fail. No, no, no. They succeeded greatly because they conned all these gamers into buying their stupid fucking failed race car seats. I'm not saying the companies failed. They did a great job selling the lie of the supremacy of gaming chairs, with LEDs in it and everything. And then probably somewhere in the early stages of that, they realized if we just manufacture these chairs, they're suddenly very fashionable. So that, you know, they're no longer, the intention is no longer for it to have gone in a car, but the ergonomics are completely lost. And if you're going to be spending time gaming, if you're going to be a gamer, first off, don't. But second of all, if you're going to be a gamer, you got to watch out for your body. Gaming is very dangerous. And the ergonomics of a chair that you're going to sit in for thousands of hours, you know, you need to get something that's going to be kind to you. I don't know if it was a good idea to wrap up these wires. Starting to kind of doubt the efficacy. A standing desk gamer. That'd be a good thing to do. Technically, the lab benches are standing, but I'm not good at standing. No, getting a dog and walking the dog has been actually wonderful for my body, my giant fat body. Although my e-waste is broadcasting to YouTube and like nobody's watching it. Nobody's watching it on that platform. That was supposed to be the discoverable platform. Then again, I think I need to look up like keywords. Like what keywords are people using for streaming electronics projects on YouTube? Most of the function that I'm getting out of YouTube right now is just an immediate and permanent archive. Oh, that one was a little squirrely. Okay, there we go. And then we just have ground and speaker out. Here's speaker out. As PC techs, we always work standing on concrete, wearing. That's not necessarily good. You should have like one of those rubber mats that cashiers use. I always love that cashiers need to stand for some reason. It's like, why do they need to stand? I understand if they're helping you like pack stuff up, but most of the time they really do not need to stand and cashier. And that's been something that people have been trying to convince like managers about. And for some reason they feel like, no, you're going to fall asleep at your job if you're not standing all the time. It's so strange. Yeah, that's not going to be good. The giant connecting cable. What a waste of solder that was. I find it impossible to find streams on YouTube. Yeah, I mean, there's just more people on YouTube, though. That's what I'm going for. More eyes on. Yes on. But, you know, it won't be, oh, that, I totally fucked that up. Okay, hold on. Hold on, wait a minute, I messed up. Angle that a little bit. Having the archive is going to be the thing that gets me more views. My views! Alright, that's not going to get in the way? Nah, that will not get in the way. And then ground. Ground, I'm going to have to do right there. So I should have done ground first. People sit and watch food videos. That's different. That's like a cultural thing sometimes, where you sit and you watch somebody eat while you eat. It's weird, but I don't, you know, it's not my culture. Cooking is popular on YouTube. I should do. You have a very glowy, pointy stick. Yeah, this is a thermal camera. Lepton 3.1 in a group gets webcam module. I love cooking. We did I believe it was Lebanese. It was some kind of a lamb stew that had squash in it, and it was kind of an amazing recipe, but it took all day to make. Very pretentious recipe, actually. Where's my ground? Oh my god. I gotta get it in there. Okay, all right. I can do this. This is the last connection. 8-hour smoker stream. You don't want that. It's just, it would just be, I mean, you know, there's something for everybody out there, but it would literally just be a static shot of meat in a smoky environment. It's like the least videoable thing. I know everybody's got something, but I don't think that would lend itself very well. All right, last connection here. I need an excessive amount of solder on this to solder it to that flat wire. And I actually don't need that much wire sticking out, so trim that back just a little bit and then add a bunch of solder to it without melting everything else. And then we can plug it in and see if it blows up. Or if it makes that noise when you're about to get a text message. That girl is poison. Bip, 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 bip. All right, ground. Once you're gonna watch the smoking streams, they get started at 3 a.m. Most of it is just a shot of the outside smoker. When it gets closer to done, she comes on and does everything to go along with it. I can't believe people would watch that. That's crazy. Oh, that's kind of cool. All right, now why doesn't it fit? Because these lines are in the way. There's so much inside of this thing to rattle. Rattle my bones! Let's see, those things are managed. Oh yeah, it doesn't feel great going back together because I've melted the seam in several places. Yule log is different. Don't you bring Yule log into this discussion. How dare you stand where Yule log stood? Just looking at the seams here. Oh yeah, it's hitting the wires here. There we go. Okay. Well, moment of truth. Before I put any of the fasteners back in, we got to see whether or not this thing works. Now, as far as a source goes, I don't really have a noise source. Let's get the desk cleaned off a little bit, and then I'll plug it in, and we'll see whether or not it works at all. I need to get some of the scrap stuff off of the desk to make room. I mean, I have the VCO, I guess I could plug into it. We know that that makes sound. Ooh, wow, why was that so violent? Whoa, that was that like burned my esophagus, that burp did. Huh. I think I need to hydrate a little bit more. Stomach is a pool of acid. Wait, no, it literally is. Acid and enzymes. Is that a passive speaker on the back? No, that's a powered speaker now. Hold on a second. Hold on a second. I need to make sense of my work area. It's all out of control. Kind of a whirlwind project where you just kind of like do whatever works at the moment. If we got to replace a resistor, we're going to be in trouble. If the resistor values are too great, they're like fully integrated into this design. So that's where this kind of point-to-point wiring is at a disadvantage. If we had a circuit board, if I like cut out a section of the skull and just made this thing on a circuit, on a PCB, then it would be easy to swap out parts. And that was one way that we could have done it, but I decided to be fancy and do the weird thing because you know, Halloween. It's Halloween. You gotta be a little extra sometimes. All right, so here's the skull speaker. And then 12 volts. I have 2 amps at 12 volts over here. I'm gonna plug that. Let's get these resistors out of the way. Jeez, this is horrible. This is embarrassing. This is an embarrassment. Yeah, putting stuff on YouTube makes me feel more professional. Like I'm that big fish in a small pond and I've just gotten into the ocean. I'm like, I'm not worthy of this. This is like a professional space. I'm not professional. But it's something I need to get comfortable with. I need to edit stuff too. Actual one-stream project. Driz, you weren't here yesterday when we started this. Not yesterday, last week when we started this one-stream project, part 2. Part-time. All right. You put a kappa in there. I missed the kappa. Where is my desktop? It's down here somewhere. Jeez. All right. Now the 3340 VCO is not quite tuned yet, but it does wibble a little bit. So we can get audible tones out of this thing. Which one was the output? I'm gonna have to look up the front panel. I guess my first test is to see that it powers up properly. And actually I should be using, well, I should use a power supply to do this instead of the wall wart because it'll tell me immediately when something's gone wrong. I'm pretty confident in my work though. So power's off. Oh yeah, I need to like, there, okay. Nothing's happening, nothing's heating up. Well, the LEDs aren't turning on, first off. Okay. So, what could have messed up? Those are the resistors for the LEDs. Those are the ding for the LEDs. That's the ground line for the LEDs. I think that would work. Everything here should function just fine. Well, that's not connecting. It's not. And then let's test that power's making it in. Just got to check all of every rock. We got to turn every rock over. Well, rock number 1 would be our connection to power, which is not here. Okay. Why am no power? Probably because the pin isn't connecting, or I soldered to the wrong parts in here. So let's see. No, the pins looks like it's making contact. What else? What else? Yeah, it could just be on the wrong tab of this connector. Although if I do, here, let's unplug this and do ohms. Yeah, no magic smoke at least. Ohms from here to here. Oh, it connects ground. Weird. Ohms on the power lines are fine. And we're making sure that that is definitely the pin. Yeah, that's the pin, but the question is ground the disconnect? But it looks like these two are connected until you plug a cable in, and then they disconnect. But are the ones next to each other, which one is the ground that is preserved? That one goes over to the tab, and the tab is what's making contact. So that should, by all means, be getting 12 volts. Let's check the voltage here. There's 12 volts. So yeah, it is in the power plug. Something in the power plug's not doing its job for separating out the pins of the little tab. This one has a split pin in the middle. And the advantage of the split pin is that it'll make good contact because it'll spring up against the outsides of the barrel jack. But if it's the wrong size, which it is, it'll not make contact. There, jeez, it's a stupid tab. Try messing with it. All right, so I'm not getting power into the device, which is a weird thing. Wouldn't expect that to be the reality. Let's just double check. We're still in voltage here. So I'm going to go from plus to ground. 0.78 volts. Wait a minute. Okay, what about from power to this tab over here? Ah, wrong tab. Yeah, that one is just disconnecting when I plug it in, because that's the disconnect tab. All right, cool. So we just need to move our grounds over to the next tab. Common thing, common. But you can see what I did there. I went sort of directly to power because nothing was happening, and then narrowed it down to the plug. That's what you got to do with troubleshooting. You got to methodically take out all of the variables that can affect a circuit. And a little bit of knowledge of circuits is helpful. And a lot of logic. This is an old-timey connector, so it means I got to use a lot of the solder. And then these, I got to pinch both of them at the same time and solder them quickly so that they don't burn me. This is why I really dislike soldering two wires to one tab. It's not a very nice process. How am I going to hold that? Hold on. Gotta like maneuver myself here. That's not right. I can't see what I'm doing. Every time I move my hands in, I end up blocking my light. I need this top bar of the desk to come out a little bit more. You guys need to be on like a headband to be able to see what I'm doing. Good enough. That'll do. Well, that power wire is getting pretty close. All right, now we get to see whether or not this thing blows up. Moment of truth. Shove that in there like that. Okay. So, interesting. Oh, I see. This actually has to go this way. Yeah, that's a little better. All right, and then turn it off. Oops. Why is this thing so obnoxious to plug in? It's ridiculous. I need to bend the little tab in here with a screwdriver or something. Get this out of the way. You're squinting. There we go. Jeez, struggle. Ooh, I heard audio. Went thump really loud when I turned it on. There's my power on glow. So, all things considered, should be able to plug. Whoa, there's smoke. Why is there smoke? Where's that coming from? Well, it's a spooky skull with smoke and everything. That's that 1 ohm resistor. Yeah, that's a 1/4 watt. So I'll need to pull that out. My magic smoke. No. The spooky skeleton got it. How much current was this thing? No, it's just mild. That's just warm. So yeah, let's just clip that thing out of there. Yeah, just on to the next project. Makes me wonder about the wire size that I'm using. I guess I'll just put a piece of wire in there. I thought we were so smart with our 1 ohm resistor. Let's see, get that out of the way, get some tweezers. Plastic smell. Yeah, we'll just put a wire in there. I wonder why that resistor caved so easily. Because you're supposed to be able to measure across a 1 ohm resistor on stuff, but I guess you need to get big wattage ones. Bone jaw. Okay. Just let that dissipate a little bit. Well, that was clippable. Spooky, smoky skeleton. Piece of wire. I just threw them out. I just threw them in the garbage. Get a little piece over here. It's on my plate from lunch. Is there a red one? Oh no, but that's speaker wire. That's much thinner than the stuff that I was using. I have this wire from like an old security system. It's a little thicker. Ghost. Everybody's got to make their little snippy comment. Here they are. All right. Man, that reeks. The light emitting resistors are kind of smelly. It did make speaker noises though. It went fup, pup. So with any luck, we should be able to make legitimate speaker noises. Mr. Speaker. All right, let's tin that one. God damn it, Short Lurker. Why is he in the YouTube space? Make him stop. The dual broadcast. I don't have the kind of controls over YouTube in order to turn that chat off. So I have to have it up just in case I need to moderate. There's one view on the YouTube video. Its only purpose is for archives. And I guess people discovering the stream in the off hours. It'd be nice to build up YouTube a little bit, though. I gotta put a lot of effort into editing now. No problem with that. I'm too much of a perfectionist, and you talk to people about editing, and they say, it gets better the more you do it. You get better at it. But yeah. So, all right, that is a really obnoxious solder job, but I'm gonna roll with that. I'm gonna roll with that. Damn it! Now there's people there. I've complained. Has YouTube done anything to solve, not really solve, but combat Twitch on the emote thing? Because, like, Twitch emotes are awesome. I don't know if YouTube has that wealth of emotes. Maybe it does. Maybe I just don't know. Crushing wires when I snap this thing closed. There's a couple points here where I could probably benefit from a dollop of hot glue just to keep things... I got banned from YouTube because of ad block. If you go into AdBlock Plus, you can release and refresh your filters, and it'll get it working for you again. I mean, you should definitely remove that ad blocker, because otherwise YouTube, those poor billionaires over at YouTube, won't be able to buy a third or fourth house. Yeah, uBlock Origin, if you get into there, you can... they've been doing a really good job pushing back on that. All right, that's off. It's like impossible to plug in. There we go. That appears to be on. Let's take a look inside of here with the thermals to make sure it's not getting too hot. Again. That resistor sure was spooky. Why are the speaker wires getting warm? Oh my god. Why are the speaker wires getting warm? It's not doing anything. Is this thing gonna pop? Alright, turn it off. Whoa, that's hot. That is hot to the touch. That's very hot to the touch. Why are you so hot to the touch? None of the component... Well, all the components are hot. But this thing is like burn you hot, which is not really what's supposed to happen. Just to see what people do for now, yeah. You can also, yeah, you can bash refresh until it lets you back in. But I mean, like, YouTube, if it was one ad, we'd be okay turning off the ad block, but it's multiple unskippable ads. You playing a mixtape? No, I don't have anything going into it yet. I was going to see how it does unpowered, and apparently it likes to kind of get a little bit toasty on its own, which is not good. That might just be how this amp functions, but I could have also hooked up something badly. What did I hook up wrong? Those aren't getting hot, luckily. If those get hot, that's when you have to, you know, run for cover. I have a feeling it has to do with the diodes. Pin 3 ground. Let's do some ohms testing here. Just ohm it out. Ohm it out between the two of you. God, that thing is hot as hell. Oh, the fire makes... Right. Sorry, listen, the streamer is going to be very oblivious when they've got troubleshooting on the mind. Only so much my brain has capacity for. It's just making you not use YouTube. That would be nice if that kind of a thing would affect them at all. I've been using less YouTube. I've been watching a lot of Twitch. Not as much, but I've been doing other stuff too. All right, ohms, ground. From here, from this ground all the way to, let's test this ground. Ohms, and then let's test up here. Oops. God, the whole thing smells like that burnt resistor now. 400 ohms. What the heck? Probably just bad contact. Hold on. Let's go to this pin. 1, 2, 3. Go to here. Why is that kilo ohms? Why is that 400 kilo ohms? Wait a minute. They charge a capacitor on the way? That should just be ground. Wait a minute. Those two are ground. This one is feedback. Yeah, that's right. And then the feedback resistor. I guess we just go back outside and touch grass. Yeah, but you need grass plus because somebody moved into that space, forced everyone, all the big companies out of it, and then remade the industry, bringing back all the stuff we hated about it, but now with less workers' rights. So pin 3 is ground. Pin 3 is a diode coming off of it that then connects to pin 4. Let's test that hypothesis. Correct. Okay. Pin 5 is power. We test that back to, all right, back to the switch. Hey, stop that. That's good too. I think maybe this thing just runs hot. Huh. I don't want it to run this hot. This is carbon neutral farts. I'm gonna up the price of farts. That's right, you jackasses. I'm fart. You have to have a subscription to Fart Plus. Ooh, you don't want plus when there's a fart involved. You don't want plus. You don't want that. You don't want Fart Plus. That's not a good thing. Reddit is good for looking up what other people have said, but I also stopped participating in a long time ago. Huh. Yeah, I have stopped posting on Reddit, but it's a wonderful consumer advice engine. If you're gonna buy something, you can look it up on Reddit, and invariably somebody will have a big stinky thread about it, which is good. Although they've kind of gotten a little worse, haven't they? Everything that we used to use has gotten terrible, hasn't it? This thing is getting way too hot, but I don't think it's not functioning. High definition tactical gassers. What? Yeah. Everything has been getting kind of put upon to be profitable, and that's making them. And for some reason, all of these executives' ideas are all from the 90s. They're all the things that we've moved out of. The things that brought us to these platforms are the things that, for some reason, these idiot executives are bringing back. It's like they can't have an original idea. It's like, why do you have all these users? Well, it's because we don't have ads that are obnoxious. And it's like, oh, well, what if we put in ads that are obnoxious? And it's like, how do we force them to do this? Water cool the speaker. No! Burn the farts. Ugh. Okay, so yeah, I mean, one of the things about this DIY design is that it is not particularly efficient. Let's just see if it can push audio. The only audio I have to give it is from this module. So this is a VCO that we attempted to tune. I did a little bit of work on this. I think what I need to do is change the capacitor on it, because the capacitor determines what range of frequencies it can do. So I think that there's just a problem with that. But I need to see what the pinout is. What's the pinout of this thing? Like, where am I plugging in to get my output? I think it's the lower right. Yeah. Pan, PWM, pan pulse, triangle pulse, saw, sine wave in the lower right. So let's plug into the sine wave. It's going to be kind of obnoxious. And let's just see if we can hear it. I may have to revise what the electronics are on this. We kind of jumped into the circuit thinking that it would be totally effective. Oh, there's more lava from my stomach. Jesus Christ. Oh man, that is blah, blah, blah. Okay. Turn this on. Actually, I should make sure that we're outputting an audible frequency first of all. We are not. Why aren't we? What's going on here? Whoa. Yeah, see, we have this, the audio is all in this range right here. It's very, very narrow range of movement. If I do this to frequency, 900 hertz, 3 kilohertz. That's gonna hurt. 1 kilohertz is your sensor noise. Boop. So this should be a little bit higher than that. It's spaghetti this morning and went back to bed. You truly are living the life. Woke up just, hey, you let me comment on that. The comment is rife for comedy. All right, so we've got a boop going into this. I'm gonna plug this in briefly. I get no audio out of it. Let's try the stereo input. Nope. Turn it back off. So there's something wrong with the circuit. Am I hearing a, is that just tinnitus? Yeah, it's just tinnitus. So it's not working. I'm not getting anything. Oh, except a little bit of burning electronics smell. I think that might be latent burning smell. But there's something wrong with the circuit, so something is not wired up correctly. Something is not wired up correctly, and that's what's causing our problems. Just do a once over here. By the way, it's not tinnitus. It's not an itis. It's not an inflammation. It's tinnitus. Get it right, internet. Do I really have to go back through this whole fucking dick circuit? This terrible circuit? Yeah, I do. I do indeed. I do indeed have to go through this circuit once more. So let's see. That's ground, that's ground, that's ground. And that grounds everybody over there. And those two get grounded there. And then the audio coming out of there goes into the audio, the plus of the speaker over there. According to the internet, it's brain cancer. Oh, okay. You can know I'm right and intentionally get it wrong, sure. This is, whoever made this disgusts me. So 2 resistors to ground there. That resistor goes to the input and a diode. That's ictus? What? Yeah, the heatsink does indeed come to life and threaten to blow up the rest of the circuit. You're human after all. You know there's something about you. Do. Let's see, those are wires going over top of it. And that is a 1K to ground. So, all right, so let's start on one end of the circuit and go to the other, because it's not a complicated thing. It's, this is the circuit here. That's not it. 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 That's it. Okay. Audio amplifier using TDA 2030. So our output is pin 4. Our inputs are on pin 1 and 2. And pin 1 goes to a 4.7 oof capacitor, as well as a 1K to ground. Now, over here, we've done a bunch of monkeying around with the circuit in order to give us volume control and power. And then in order to take in Eurorack level signals, I've put a 5 kilo ohm resistor on this, which may be a mistake. I don't know. That might be a mistake. I don't know. Just trying to attenuate it. So, let's see here. Audio comes in on this half of the skull, and it goes through its resistors that I have set up. And that goes to this junction here. And that goes to the terribly soldered purple wire that comes around to the other part of the skull. And then purple goes into the potentiometer. When this thing turns on, it'll wipe that potentiometer for up to an extra 6 kilo ohms on that line. And we checked to see that this is the right direction, Because if we wire it up the other way, as soon as you turn it on, it would be at full volume, which is not, that's not something we want. Then it goes into the positive side of the capacitor. Positive side of the capacitor, whose output goes in two directions. Ligma on what? Let's see. That goes into there, and then it comes out here, and it skips over this. Ligma on toast. Ew. Wait, ew? I don't know. And that should be a junction. Hold on. Wait, that goes there. Where it just barely avoids. Huh? Yeah, there's wires over top of it. Okay, let me get tweezers to poke at this a little bit. Ligmania. Let's see. So this comes to blows right here. I guess our audio signal isn't... Did I not finish the audio signal? This is part of the audio signal right here. So the audio signal then comes to this resistor, which it should be one resistor that goes to ground. That goes to ground, but then I don't think I made the next jump, which is to go to pin 1 of the... Oh, yeah, we did that outside. So yeah, that resistor, which one does it come into? Second one. It comes into the second resistor, and that resistor goes also to ground. So the ground is out here, and then over here we have pin 1 flexed into it and soldered on top. That's pin 1. Okay, so far so good, right? So far, all of this stuff is correct. So now we do the feedback. I have a feeling it's the output that's screwed up. Or if I didn't screw anything up, then it's just like runs super duper duper hot. That seems weird that it would run super duper duper hot. So now we're looking at pin 2. Pin 2 is connected to 2 resistors. So I've got one resistor here that goes to pin 4. 1, 2, 3, that's ground. 4 has a little sneaky sneak right here. And pin 4 also goes out to the speaker. That's the feedback resistor. That one right there loops over to here. That's what this one is doing. Wait, no, that's what this one is. Yeah, that's what this one's doing. The one that goes diagonally upwards, that does our feedback. Okay, so the other one that is connected to pin 2 goes to ground. How is that connecting together? The other one that's connected to pin 2 goes to ground. There's like all kinds of garbage going on in this circuit. One goes to ground and the other does feedback. So I think this one's the feedback. No, this one goes to ground. This one does feedback. Let's just double check that with the multimeter. So I take the multimeter, I go to ohms. I go, hey ohms, what's happening, man? Did you guys get it? There's a little joke about ohms. I made a joke. It was about ohming and ohms and stuff. That was cool. I remember that joke. That was a cool joke. So that one, the one next to the diode, I saw briefly just a flash of lucidity from this thing. There we go. And then the one over there doesn't. This one does. Yeah. So pins 2 and 3. Sorry, 1 and 2. 1 and 2? Yeah, 1 and 2. These two right here. Those connect both to ground. Then there's one all the way out here that... Who's that? Ohm domes? Neuro derp. What? Okay. Anyway, all right. Pin 2 we have on lock. Now, let's just, for double checking purposes, Because that could be, the feedback loop could be messed up, and that might be what's screwing this thing up. I'm going to make sure that one of these pins is going to that pin. There we go. 400 ohms. Seems a little generous. $400 is a lot. Why do I have 400 ohms? Is there a bad connection? I mean, I would assume that any problems that I'm having are due to... Pin 3 is not grounded. Wait a minute. U to ground. That could also be the problem. Pin 3 is not grounded. Oh, wait a minute. There it goes. No, 8M. Just double check. Yeah, there's no ground on this pin. Okay, well there's our problem. Oh, and there was the hole that I should have used right there. Oh, I see. There's two holes next to each other. I'm going to make a new hole. I'm going to drill a hole right here. And then that way I will be able to run... Telling me there's no grounded pin at all? Yeah, that's it. It wasn't grounded. But maybe with a ground, this thing will be a little bit more cooperative. Hey man, if you can wrap a burrito, you're in good shape. So where am I going to get ground from? Let's see. Ground is like way down here and up on the right side of the circuit. So were I to... Oh man, not easy to maneuver. I'm just going to have to do a wire that goes in and I fold down against this ground. Or no, it's got to be above. Because there's other stuff there. Oh my god. How the hell? There's a second hole in here that I need to be using for a different wire. So maybe if I get rid of that one, I can pop that wire over to the side and then I can have my ground wire. Because here. I came from... Yeah, see... There's a wire here that comes from... Oh, that one came from the other side. But there's a hole here, and I ran a wire here. If I reverse that and move this wire out there, then this one can connect to ground. So let's do that. All right, gotta get this out of the way. That was on me. That's my bad. It's always my bad. Let's see. I don't have the stand in here anymore. All right. Let's do this from far away. Yeah, everything is in the way now. Can't get in there to solder. How am I going to do this? Okay, that's the wire that I need. You guys, I need to see, working on this has required me to sort of solder in ways that I hadn't expected, and that makes it tough for me to set up the shot. Because this thing doesn't stand up on its own, and it's a skull shape. Oh, that might be bad. I think that's melting through the plastic. Instead of directing itself, it's just melting. It's going to be a big head injury that this skull is going to sustain. All right, let's try to get that out of there. Try to get that out of there. And I'll have to put it into the hole that it's supposed to go through. So the more I flex these wires, the more they're prone to breaking. What are you saying in chat? Because no, I can barely police you. You must behave. Okay, that got that out of there. I might have... Oh, talking about calling and gossiping and then hanging up on you. There's a whole thread about that on Reddit. All right, so now I need to get this into the other hole that's there. That's actually right. Is that the one? Seems like a weird place. I don't know. Make sure I identify the right one. All right. The problem is I can't see anything that I'm doing. It's like just putting my hand in the right spot is oh, now I can't see the holes. Oh, that's good. This needs to be angled so that I can make it in there. That. And then the hole is right there, or is it one? What I'm looking for is which one? Oh, it's blocked by a wire. That's why. Need to view the light through the holes. I don't see it. Just use a little wire scrap and poke it down. Where did the hole go? Damn it! I can't see anything. I'm blind. I keep complaining about it, but yeah. It's important to be able to see what you're working on. Here, I actually need to part this thing from the plastic. The pulling the wire through pulled that up. There we go. Move this away so that I can access the ground hole and the one that was next to it, which I'm not seeing. Man. Okay, let's use the microscope. The aftermath of my tomfoolery is that I can't see this stuff goes through. I could just heat the wire up and poke it through, but there was a hole. I think it's like right on top of this. Is that it right there? I don't know. I can't see a damn thing. Dreamer, I can't see anything. Crazy that without a ground it ran away like that. I wonder what it was doing, how it was functioning. Why it was heating up. How could it pull so much potential without having any... Maybe it was going through the speaker. All right, probing around like this isn't getting me anywhere. I had a pretty good idea of where I was going before, but then I totally lost sight of it. There's the one hole right there, but then there was one that was unused in one of these locations. Well, maybe I just drill a new one. New holes. Who dis? The plastic didn't much like me pulling on that wire. It kind of pulled stuff down and sealed around where I needed to be. We'll just try drilling another hole. Oh, you guys need this other view. Sorry. Drilling another hole. All right, and then let's go just to the right of this. Luckily, this plastic is very easy to work with, very soft. I almost felt like there was already a hole there that I just drilled through. Okay, that one's nice and easy to see. All right. I think I must have like ironed over the plastic or something. Oh, come on. Oh, there we go. I was going for the wrong one again. Here's our feedback resistor. I just solder everybody together. Everybody gets soldered together. I'll make it look a little less obnoxious. And that opens up that area for me to do a ground connection. I forgot to. I forgot. All right, look good. Now, because of all the stuff that I just did with removing that wire, I think I ironed over the holes. So I need to drill another one next to our ground pin and actually get ground to the right pin. Although, where should I be? Probably as far up as I can so that it gets away from stuff and I have the chance to get to the hole in the back panel area. God, it's already 4:30. Jesus fuck. How long have I been working on this thing? This is the part 3 of a one-stream project. We're not working on this thing tomorrow. We'll be working on something else. Oh, well, Wednesday I don't stream. Thursday, I mean. We'll work on something else. Let me get a sacrificial... Did I have a sacrificial resistor over here? I think I got rid of one. Yeah. How wasteful. All right, let me get another sacrificial resistor then. And we can have that pop up from there. Let's play spooky music today. It has to be today. Of all the days. How could you let this happen? All right, let's just grab a rando resistor. I do have another kit of resistors that's more organized, but I keep buying them. Keep buying resistor kits, and they don't have the right size for me to work with on the breadboards. All right, so I'm going to put a little angle at the top of that, and that's going to solder to the diode. Of course, it's totally visible here. It's the spec. These 4 pixels are the wire that I'm soldering in. I could tin it ahead of time. I'm probably going to burn myself if I do this. These drill bits are threatening. They're like right in front of me. Move them away so don't break them. Yeah. Too much stuff. Oh, it didn't actually get hot. It didn't get that hot. I was able to tin it without feeling it. Yo, I'm feeling it. Okay, nice, big, easy to see hole. And then that down like that, right across that pin. And then I touch it with the solder. That didn't do it. That didn't do it. Get a little solder in there. Ah, this thing is unwieldy. It's hard to work on because of the shape. I guess I could make all kinds of tooling to hold it steady, but it wouldn't be worth it. All right, there's the ground wire in. I guess I could have run the ground wire back to here, and that would have made it easier to work with. There it is. And it looks like I can just fold this down and get it to touch to the main ground bar back here. Yeah, the only issue I have is that it's going to be difficult to solder without other stuff removing, like the main ground wire that I just did. But at least that gets our ground to the right spot. I guess I could go. Can I go down this way? Yeah, I'm gonna go down to the bottom where those other grounds are. Oh, great! They just bent it into a weird shape. You guys get out of the way. And then this, I need to come down this way. You kind of can see what I'm doing. Kinda. It's much easier for me to use this ground down here. You just layer it on top of everything, like a cake. A cake fart. No, gotta, because of the bend that I put in it, it's like the wrong position. You need to just coax it to go the right way. Now it's sticking up, and I don't want it to stick up. Full complaints today. My greatest Halloween costume was the LED globe, because I was up until 4 o'clock in the morning the night before, like programming the LED patterns, and I found a like a matrix that you apply to the LEDs in order to use less battery and make the colors more true to what people see. I put it in as a mode at the very last minute. It got me 4 hours of battery time on that thing. I resurrected it at one point. I think it still works. I may have to revisit that, because it was audio reactive and everything. Of course, the things I could do now with 3D printing and our knowledge of LEDs. You just got to get that first letter right, otherwise you're in a lot of trouble. And one even looks like the other, so you don't know if it's a lowercase L or a capital I. Matrix L? The matrix was a W. Hold on a minute. This still isn't very well connected. There, okay. A lot of burning plastic smell suddenly. What? A equals LU. Wait, what are you talking about? Oh. Yeah, I guess you could run into that in certain spots of math. Especially when you're throwing constants around. Please stay back, wires. I don't need to deal with you right now. All right. So we now have ground, where ground should be. I forgot to ground the amplifier, and so probably ran away with some kind of a signal. You can decompose some matrices into lower and upper triangular. Oh, okay. This is a math meme that I am not, I have been outside of math education for too long to understand. It's gone too far for a bad joke. Sorry. I have streamer obliviousness, oblivation. I don't fucking, Yeah, I don't have the ability to understand complicated concepts when I am going in a completely different direction. Okay, now we get to see whether or not this thing lights on fire. I mean, we had a nice smoky resistor back there for just a second, but now it should actually just work. So off is off. Well, that's always nice. That appears to be turning on. How quickly do we get warm? It is not. Ooh, that's dangerous. Did that come undone? It is getting warm, though. Anything stupid hot? Yeah, that appears to be getting a little too hot. Still. I mean, it's got its ground connection. See if we can hear anything. Nope, absolutely no audio at all. Let's try the other one. Why do you forsake me? Possibly could be too big of resistors on the input. At least my LEDs kind of work. Ooh, yeah, that's too hot. Wah! Wah! Turn that off. Let it cool down. So something else is wrong with it, and I'm not really sure what. Pin 4 output on, yeah, that and then that, because that crosses over. There's not much else to this circuit, so I don't know why this thing isn't working. I think maybe it's the fact that there's not much to this circuit that's working against me. And it could be that my input resistors are too big. In which case, I could short out the resistor and see if we can hear it. My greasy hands making this thing all gross. That's full volume, and then I use the tweezers on this resistor. Explosion! Nothing. So something is still broken about this. What could it be? Oops. Oh, wait a minute, I didn't have audio on. The LEDs fade when I do it. I can hear it. It's very quiet. Very, very quiet. Why is it so quiet? Yeah, if I short out the resistor, it doesn't get much louder either. Uh-oh, that's getting really hot. I gotta let this thing cool off. So I can hear it. It's making an output. It's going through a smaller speaker. And I can definitely hear the audio, but it's very, very quiet. Ow! Jesus Christ. And I'm giving it a full 12 volts. More volts. It's getting 12. And it should be low. I mean, it only gets slightly quieter when I short out the resistor, the input resistor. So, I don't know, some gain stage isn't happening quite right, and it might be down to the design. The lamp I built is 9 volt, but it's awesome at 15. I don't have this hooked up to the power supply to be giving it extra. I mean, I know this chip is good up to like 20, but this design was specific to 12 volt, and the 4 ohm speaker. So I wonder, I mean, if I want to up the gain stage, I could make one of these 1Ks smaller. Yeah, the audio was coming from the speaker. Which part is getting hot? The center part, U1, is what's getting cooked. I don't know why it's getting cooked either, because it's not like we're asking it to do that much. Unless something's wrong with the diode. No, nothing's wrong with the diodes. They're just very old diodes. C2 is in there as well. We're giving it 12 volts. We're giving it ground. Let's see what they say on the site that we got the circuit from. What? Why are they trying to sell me stuff? pin 5. Yeah, we got that right, I think. Pin 5 over to VE. 4 is output. VE minus, non-inverting. Detailed description of the pinout. Look at the circuit. The operation of this audio amplifier circuit uses IC is quite simple. First, we're providing a 12-volt DC supply. You use 6 to operate the circuit. Audio input device such as a smartphone or microphone is used. It's then passed the input through the 47 UF. The circuit is effectively blocking the DC component. The input signal using a coupling capacitor, letting only AC pass through, and then we wire the capacitor to the output of the IC's non-inverting pin. The amplifier amplified output is subsequently delivered to an audio transducer, like a loudspeaker, with flyback diodes to prevent the amplifier from negative feedback. And audio electronic devices like headsets, blah, 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 blah. So what the hell's going on here? Why isn't this working? We could have just, like, broken the amp, I guess. I don't think that's really... Oh, 1 watt loudspeaker. This is a 5 watt loudspeaker. So, I mean, maybe that's part of it. So TDA 2040, 4 ohm, 5 watt. That's what it said. It said a 1 watt loudspeaker. I know that's not the right term, but that's just what it said. Is it this thing? 25 watt audio amplifier. Oy. 17 volts. Plus minus 17 volts. What? $680 and 22. And use a 0.1 on the input. It might be down to tuning the resistor values. Yeah, see, 680 and 2K. See, it's possible that I would changing out the resistors is not going to be. That's not a thing, Chad. Not with this design. I guess I can clip the leads and then put another resistor in and then solder it. That's the only way that I can really do it. What do we have? We have a TDA. This thing really does get hot, though. Like, that's not good. It getting natively that hot is not a good... That's not a good scene. TDA 2030. Why are you getting so toasty? I mean, the other thing I could try is cutting off the amplifier stage of the original circuit board. Putting this in there, and then just having audio go into that amplifier chip. I'd have to figure out where audio is coming into that thing. There's a lot of stuff on here. I don't really want to do that. That's like a 5-volt board, too. Peak current limit, TDA 2030, 3.5 amps, 9 watts. 14 watts from plus minus 14. Well, you know, we're running it under, and plus, we're doing plus 12 volt to ground. So it's like we're operating it on 6 volts. Yeah, there's a bunch of circuit stuff, and this is basically what we built. 1 microfarad and then 22 micro on that for some reason. I don't know what that's doing. Of course, this is driven with a plus minus supply too, so that changes things a little bit. But if I do 680 and a 2K, oh wait, no, 22, this is an optional part of the circuit, I guess, to prevent ringing. Huh. That could have involved all kinds of electronics. I think I have a 330 pico through hole somewhere. Well, let's not rock the boat too much there. We can take the 680 and a 2K, and we'll keep the 22K is a very weak pull down. We have a much stronger pull down on ours with a 1K. But if I do 680 and 2, then it'll become a little bit different. It'll be more groundy. Diodes both point out. Well, no, they both point out if you solder them to pins 4 and 3, like I did. So I have them, they look like they both point the wrong direction, but they're on pins 3 and 4. So I flipped the script on that one. One of them loops back around and goes to pin 4. So this one here, with the band facing outwards, loops back into the bottom of that chip, and then you have the other diode that goes to the top and to plus 5 volts, or plus whatever volts. Plus volts. So yeah, this pin goes down and then across to here. I'll show you. And I did that intentionally because the one lead on the diode was short, because it came out of a through-hole stand-up kind of affair. So yeah, there and there are connected to one another. No. 1, 2, 3, 4. Oh, no, it's there and there. And then this one goes to ground, and then this one goes to power. Power is this pin. Like that. And then this one goes to ground, which I don't have anything for. We did fix that, though. So the resistors that I would have to replace would be the feedback resistor, which I think this one and this one go to ground. One of them is the initial 1K. Pin 1, yeah, so we wouldn't touch this one, but then this one and this one would be replaced. So I'm going to clip them out, and then I have to solder them from the other side. I don't know if I like this circuit, though. If it's getting that hot, I don't know if I like that. I don't know if I want to preserve that. This might just be a failed attempt. I'll have to revisit it when I have a better circuit. Also, I did buy these. Those are powered speakers. They're probably way more efficient. My spooky day failure. Okay, so the two values, the input was 680 ohms. So let's find 680. See if I can't get this thing duding its skeletal tone. I need doots out of this thing. And maybe I'll think about like a flat surface mount circuit, and we can do the copper thing with it at a later date. We'll return to Skull Island. What was the other one? 2K? I only have 2.2. Yeah, close enough. Good enough. 1R. Yeah, you were the reason that we had smoke everywhere. These are so disorganized. So I need a 680 ohm, and then I need 2K. So here's 2K2. 2K is on the one to ground, which is going to be the one that's closer in. So this gets cut close. And this gets just bent straight down. Yeah, I only clipped one of the leads of that. Let's desolder that so I can get to it. The only problem with doing point-to-point is when you actually have to tune it. That's why we should do things on the perforated prototyping board first. Then I could have found out, wow, this thing gets hot. And it wants to explode. And it doesn't like the values of the resistors initially. I did hear audio coming through it, though. So I heard it. I heard it. That's one of them. I have to solder that on the other side, but I want to get the second resistor first. The other one is 680 ohms, so that's like really small. I need to organize these. I'm probably going to do that tonight. All right, 680 ohms. 270, 390, 470. Here's 680. And because we have 2.2K, I'm wondering if I need to lower 680. We'll just go with this for now and just see what it's like. You can always clip it again. I think I like the idea of the gold, the copper, rather. Copper tape all over this thing. I have to figure out what a one-layer speaker circuit that uses some of the more... Supposed to pass out tricks to all your neighborhood kids. We don't have any. The only kids I ever saw in this freaking neighborhood, we were living like a little polyp, like a little isolated neighborhood. And the only kids that I've ever seen, ding dong ditched us. I don't know what you guys call that, but they rang the doorbell and ran. They just kept running. We don't get as strong of a Halloween scene. Otherwise, we would have been working on animatronics for the past months in order to make something that was, like, totally cool. My garden is scary enough to keep them out. You got to do, like, a garden project, like a garden electronics thing, like this light-up staircase or the floppy drive thing. Actually, that would be pretty spooky. You have the floppy drives playing Spooky Scary Skeletons. Oh my god, this is such a mess. This circuit is such a mess. It'll be so easy, Bother said. Just a quick little thing. Oh, Jesus Christ, what just happened? Okay, that was just the tweezers slipping. That doesn't really look all that soldered. Alright, back into it. Back into it. Now it is. Amp op are still complicated? Yeah, man. Well, you don't think they're complicated? All right, where are the other leads? I got that one there that I can just solder directly. So we'll clip it. Oh, where did I just... there's wires that are right there. The more I work on this circuit, the more I feel like a surgeon. Flopatron is someone else's? Oh, yours is floppy organ? Okay. Floppy. Of course it would be called that. I have to be acutely aware of where the soldering iron is here because it's completely surrounded by really, really low temperature plastic. We didn't spring for the thermoplastic on this thing. All right, there's that one. That one is connected there, so I can cut that real short if I can get the iron in there. Okay, and then bend this thing down along that path a little bit. Give me something to solder to. Make sure the iron's on. Now I gotta get all the way in there. Jeez. Nope, didn't do it on the breadboard. That's the problem. I didn't test it out ahead of time. This would have been a very easy thing to detect on the breadboard. We didn't do things properly because we're having fun. I poked a massive hole in this thing. Oh boy, that's not good. Went too far deep. Huh. I think that's connected. Yeah, I totally sank the that part of the circuit. All right, let's try it. Oh God, I was plugged in the whole time. Oh my God. All right, come on. Oh, it's this wire stuff is right in the way. Go. Spooky speaker, go. Why is the tone changing when I turn it up? All right, that didn't do much. Okay. What the hell? It's like super duper here. If you guys can hear that, this is what it sounds like. And then I turn it down. When I change the volume, it changes the tone. What the heck? This thing should be controlling the tone. Oh, it really favors the higher frequencies, huh? Oh, the knob is backwards. Yeah, I mean, it is amplifying, but this is getting way too hot. So I think it is working properly, and if I play with the gain a little bit more, it would work, but it's got this nightmare of a fucking fire going on the top of it. I don't know if any of these mention heat coming out of the amplifier. I even gave it a heat sink. It makes me think maybe I'm driving it a little bit too hard. Maybe I need to go down to 6 volts or something. I think I have a 6-volt amplifier anywhere, but it's like a little too... we need a better amplifier on that. We need a better amplifier. This chip is just way too hot. They're running it without a heatsink, though. No, the heat's not the problem. I don't think the heat is what's going on here. Simple chip-powered amplifiers, very popular, having started in the 90s and early 2000s. An application similar to here, but some ideas. A pair can form a capable amp for a stereo system. A pair can be used to improve the sounds from a TV, beefing up 400-watt plus amps in PC speakers. Really? That's literally the project. Tweeter or mid-range amplifiers and bipolar, blah, 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 Bluetooth speaker, active hi-fi. I mean, they're touting this thing as being so awesome. Typical applications, ST microelectronics. So the typical application is going to be in the data sheet. I think we had a link to the data sheet nearby. It was like here. Blah, 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 PCB way, blah, 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 TDA 2030. Identity check. What? Get out of here with this. There we go. There's those random ad links that are peppered in articles now. Monolithic integrated circuit in the pentawatt package. The pentawatt package, please go away. I don't want this there. There we go. Monolithic integrated circuit in a pentawatt arrow package. What the hell? what? Huh? Intended for use as low frequency class AB amplifier. 14 watts of power. 12 watts on a 4 ohm load and 8 watts on an 8 ohm load. Oh, so we should be able to get 12 watts out of this thing. High output current has very low harmonic and crossover distortion. Further, the device incorporates the original patent short circuit protection system. So why are you heating up so much? This thing shouldn't even be breaking a sweat. They've got a 1 ohm and a 220 NF across there. This is the circuit. I mean, this is pretty much what we've been doing. Although here we have 22 kilo ohm wiper in order to adjust volume. Interesting. There's a little bit of extra stuff going on. So 4.7 and 150K is what they use. I don't want to replace the resistors again. This thing got way too hot. It seems like in a good application though, it shouldn't get hot. So I don't know what the problem is, but I'm gonna abandon this because I would rather do the circuit on the skull using copper tape. I think that would be cooler. We had that idea mid-project, but I feel like we finished, like we got it to work. It just does the plastic conduct? Huh? No, of course not. That's super weird. No, of course it doesn't. I don't know what any of these thermal numbers ever mean. Like when they talk about like thermal conductivity and stuff. Well, that's different. That's different. This is a cheap speaker in a skull that looks fun. And this is gonna be my mutant speaker head. But this is a big problem. This is getting way, way, way too hot. I don't know why it would be getting so hot though, because there's like nothing to this circuit, right? Does this thing always just get that hot under 12 volts? What if I give it 5? Will it get that hot that fast? Let me see what other power bricks I have that might be able to fit into that plug. What power bricks? I'm running out of power bricks. Used up a lot of them. That's a laptop brick. Let's see. What is this? I don't really know if I have anything. Oh, there are these. Julian was looking for these. These power splitters. He uses these a lot in his modular setup. Another damaged part. That could be too. Yeah, something could be bad about the internals on it. I wouldn't know. I wouldn't be able to know that. Unless maybe I like ohm it out in just a particular way, but... And it may have been damaged by our powering it up without the thing plugged in. What's this? This looks like it'll fit, and it is a Netgear 12 volts. Damn it! This is all I have left, 12 volts. Oh, it fits in much easier, but it might not make contact with the barrel part. Ugh. Ugh. Not a good feel. All right. Trying to find. Maybe I'll just give it 5 volts in the power supply. Where's that plug that I had? I was using it for modular stuff, so it was maybe over here. Oh, looks like a no man's land of horribleness, all the terrible mess that has generated from these projects over the past couple months kind of coagulates in this area, and I do not see that barrel plug that I had. I had a DC barrel plug that I could hook up to the power supply that would allow me to give it. No, I'm not going to put it through a buck converter. That's like way more effort than what's required here. Now, keeping it simple. This is another 12 volt power supply. How many of these do I must have gone through and like reduced. What are you? 10 volts. Okay, now it's just messing with me. It's a totally different jack anyway. All right. Yeah, I don't know. Let me just find that barrel plug thing. Hook that up. Why is there an empty plastic bag in there? Let's see. Yeah, all the evidence of what I've looked up so far, I mean, people wouldn't be suggesting that you just go and build a circuit like this if it heats up like madly like it has been. So I don't think that's a thing that's supposed to happen. No, we're going to use a power supply. We're going to do this properly because that way I can see how much current this thing is drawing. drawing. That's an important thing to do. So I need to strip these wires and get them on the power supply. Hopefully the right direction. These. Two views on YouTube. Hell yeah. Really moving up. I'll be out there rubbing elbows with all the big YouTubers. All those millionaires. Now we play the, which one is the pin game? I have a feeling that the, what is the marking on this? There is no, okay, there's a dashed line, which often means ground, but sometimes it means pin. You never know with these things. Oh, but my multimeter is sitting right in front of me, and it is flipped to ohms. So I will just simply test the wire. That is what I will do. We can basically, through this, we could see that it's drawing just a ton of amps. Yeah, so the stripe is positive. God, my test setups are like layered on top of other test setups. It's out of control. All right, turn that on. Takes a second. Let's see, currently I have it on 12 volts. If I turn that on, 6 amps, and it's dropping down to 3 volts. So yeah, something is seriously wrong. It's drawing a shitload of current immediately. Why would that be? Power goes into there, gets switched on to there, turns on the LEDs there, and it goes to this juncture where it connects to that part, and then it goes down, and actually I think maybe that is a problem. All right, so there's maybe a short to ground somewhere on this thing. Not up there, so that's where that goes to power, and then, God, the shadows are so bad. I'm losing my mind. We need to work on like a regular circuit board next, just so I don't have an aneurysm. It goes to that messy solder crap right there, and then one of them comes over and goes to the 5-volt pin. 5-volt pin does not interact with anything else. Looks like it almost shorts to that, but it doesn't. So let me just bend that with a pair of tweezers. Just ensure that this does not make a connection. Oh, and then throw it into the one next to it, the pin next to it. And my soldering was kind of lazy at this point of the project. There's definite separation there, so that's not what's shorting out. It could be a bad chip. Because, yeah, that comes across here and goes to the capacitor, and the capacitor goes to ground. And none of those are making a connection. That's 5 volt or 12 volts there. And it comes back over to here, goes to there. This is where it hits the diode. And the other diode is up here. That one. I think I got my diodes backwards. Maybe that's what it is. I might have gotten my diodes backwards, and it's busting all the current down to... Because this one, okay, so this diode is coming out of pin 3. Pin 3 is ground, so it goes over here, and then it should go to pin 4. I guess this is yeah, no, that's correct. Because then the other one goes to power. I think it might be the chip at this point, because I'm not seeing any glaring issues. Wait a minute, this might be a glaring issue. This might just be a glaring, horrible issue. Oh no, never mind. That was just the sidewall. I thought that was another wire in there. It's my vision problems are compounding on one another. Why would this thing then draw full, like all the way up to 6 amps? What could be the problem? What is shorted out? I think maybe the chip is blown up, because that's all that I can come up with. Everything is very cleanly connected on this. But why would it blow up like immediately? Right? It should start working and not just be immediately destroyed. I could swap out the chip. Not easy to do, but I could do it. Maybe that would get it working. Should we try swapping the chip out and see if it blows up? Because every other part about the circuit works under, this is my understanding. LEDs are fine. Whether or not that is connecting, it doesn't look like it is. That goes right through the 2 legs of the thing. That goes to the speaker. Yeah, I don't see why it would be such a trouble. Of course, the knob goes the opposite direction that it should. Yeah, it drops down to 3 volts at 6 amps. Oh, hello. Hello, warm diode. Why are you so warm? What happened to you? Why are you the warm one? Why are the diodes heating up first? That's a problem. So, 1 in 4007, getting to its breakdown voltage. These are pretty old diodes, but I don't think they would have gone bad. It's just, did I wire them completely wrong? Because on pin 5, I should have, so let's check this very carefully. Pin 5, I should have the line end of one of the diodes on. So let's get the multimeter, and we'll do it by ohms, because that's the easiest way. Doing it visually is actually kind of difficult. And so this is power here. That is wired correctly. And then this one is ground, which I don't know where I can find ground. Oh, the heatsink is ground. And then the, wait, that one's power, so then this should go to here. What did I just measure that to there? Well, okay, there's the problem. I've got a ground that's connected to the output. Because this is supposed to go to this pin, which it does, incidentally. So the one down there does not connect to ground. I don't think I had it connected to ground. Looks like it gets damn close to ground, but it doesn't connect. There's no connection to ground. So maybe my diode is busted? Might be a bad diode. Have any reason to distrust these? Where's the other one that I got? Here's one of the diodes. They shouldn't fail closed. So in reverse, nothing. Forward, it should be less than diode voltage. Now I got kilo ohms on it. Oh, that's a bad diode. I don't think I wired anything backwards like that. Did I? That goes to power. And that shouldn't go to ground, but it does. Yeah, that's a bad diode. Bad diode. We got a bad diode. Now, is it only the one? Because both of them appear to be heating up. Oh, that's the wrong one. I could turn that one off anyway. Seems like it's maybe just the one, but I guess maybe it drives the other one to its breakdown. Huh. Okay, so how do I get you out of here? Can desolder the one. Maybe the other. The other one is sunken in the plastic, so it's gonna be kind of difficult to get out. Tweezies. Whoa there, buddy. Hey there, buddy. Why don't you calm down? Go. Check to see if there's anything wrong. No, looks like it's just bad diode town. All right, so we're gonna strap this one onto the other one. So I'm gonna cut the actual diode. Well, let's test the diode now, actually. Make sure that it's that. Now that I have one of the leads exposed, I even tested diode mode. See, that says 0.5 volt. Ah, but it shorts that direction. No, it shorts both directions on that one. Wait a minute, what the fuck? Ah! I'm totally lost. What does the other one test? I gotta hold it. Test is the same, so I don't think the diode is bad. Either the circuit or the chip now. For some reason, this here to here is like, so let me just take the chip out, I guess, and just see what's going on, I guess. Could be a bad chip, I guess. Seems a little far-fetched. These things should be pretty survivable. And they work on 12 volts. They work on all kinds of volts. Just violently removing this. It's kind of a tough process here. The violent removal of a circuit element. Ow! Now it's getting hot. Jeez. Okay, hold on. Oh! Oh, damn it! Went all the way to the floor. Let's see here. I didn't, you know, the TDA, whatever this thing is not that fragile. I didn't think it would die like that. But it seems like it's the part of the circuit that's dead. Is that still soldered? What the man? This thing is just holding on for dear life. It's getting too hot for me to touch. Ow! And then I go and do it that way. Okay, fingernail, help me out. Jeez. Everything's fighting me today. It's all fighting me. Fight, fight, fight. Fight night. Okay. So yeah, none of those are connecting to each other. They look pretty good. Let's double check the wiring. Make sure that without the amplifier there, everything is properly connected. Use ohm mode. Well, let me check the diodes first. Oh, hello. Hello, broken diode. That is a broken diode. Volts for the diode. Beep. Flip it. Beep. So either that is wired funky and going to the wrong place, or, and this is the real answer, that something's wrong with the diode. All right, so I'm going to get it out of there. I'm going to have to replace the whole thing. My head is beeping. My skull. The beeps. All right, so one of them is a bad diode, and maybe that killed the amplifier, or the amplifier is still perfectly fine, and we got the wrong guy. There's a one-armed man. Where did my tweezers go, though? Need those. All right, so I'm going to finish this thing up on my own. I don't need to drag you guys through the streets on this one, but you know, hey, spooky day. It's the day of spookiness. And yeah, I totally failed to make a circuit. What an introduction to YouTube that was. Hey, I watched this O'Bother guy. He can't even make electronics work. He's terrible. He's absolutely awful. Owie. Owie. Ouchies. Oof. Ah, my head. My bones. Right. I see. All right, that's an easy one. It's getting in the way. There's a big like booger of solder on this one wire. That's like just right in the way. I'll just cut that a little closer. It's when you start rushing like this, when you want to actually like get something done and finished by the end of the day, that you make all the mistakes. This is when the most dangerous time is. Rush something and then you don't think about what you're doing, or you do something a little too quick, and that's when your $15 microcontroller explodes in front of you and you feel bad. So it's a good time to take a break. Boss man might not like that, but the mind needs to rest. I'm trying to there's a little piece of wire in here that's like really obnoxious. It's kind of looped up and around, and I can just cut it. If I cut it, then it means it's going to be pretty short to work with over here, but that might be okay. See if I can just bend it into shape here. Now, is there a wire that goes up to that? I think there is. Just going to make sure that all these inputs have their little individual wires in a position that won't short. Solder? Oh, it's way over there. Let's get that soldered. It's like a circuit is getting nastier and nastier as time goes on. All right, whoa, jeez. One of the biggest things I'm having trouble with when working on this is holding on to a skull shape. Trying to get that to wrangle into the right positions. So pin 1, 2, 3, 4, and 5. So let's get a new one of those chips and let's see if that works. All right, into the bin. This is the only other one. This mad assortment of op amps and stuff. I mean, I have other like speaker drivers in here that could be used, like a 386, I believe. But it also came with things like heat sinks and this madness. This thing is insane. This is an SO8 to through-hole adapter. I guess if you're in a serious situation where you really need to replace one of your surface mount op amps with a there's no light. There's no light anywhere. Yeah, it's just got this little breakout there, and then it goes to a surface mount pin header that is about the size of an SO8. Madness, just madness. But yeah, it only had 2 of these, so this is the only other one. This is our only other chance to get this to work. I don't know if 12 volts to the dome would break this thing. I don't know if that would break it. Just hitting it straight to the output with 12 volts. I don't really think it would. It might be that chip is still good. I gotta flatten all the pins now. So let's get the big, I have these big wide pliers that I like to use for flattening pins. One way to find out. I don't want to go through the trouble of soldering it right now and having that not work and then going, well, there was a problem. I want to finish. I want to go eat dinner and take the dog for a walk. I stream in the middle of the day so that I'm not idle all day. I don't do nighttime streams. So that's where Uda Oo was like, man, I want to collab, but you stream during the East Coast normal time. But yeah, it's like I don't want to be idle, so I do these hours. I want little feet at the bottom of this thing. Hopefully that's the right distance. Get that to 90 degrees. You get one bend in these wires. You got to be careful. So now that's got little feetsies. I'm going to cut off most of the feetsies just so I have little pads at the bottom of these things to solder with. There we go. Little feeties. So I have taken your weird dip package or whatever this is, and I've straightened the leads. Oh no, they need to be a little, well, I need to spread them out a little bit for them to go to the locations that I need them at. Should have worked within the original parameters of the thing, but we're not that cool. We did it our way. These are going to fan out a little bit. All right, so these need to go, well, they can't go under a lot of them. Oh, there we go, that works. That works. I'm just going to have to manipulate it a little bit afterwards. All right, screw right there. I'm going to put the screwdriver away. Here it is. I didn't think I'd do this part. Didn't think we'd get this far, but we're going to hopefully have a wonderful payoff at the end of all of this, so the speaker works, and I can finally be happy. All right, so let's get all this stuff in order. These fan out pretty wide, actually. Also, this is moved over. All right, yeah, assuming that those will make contact. Oh, that one's pushed into the skull. Jeez, there it goes. Okay. That's going to push forward in order to do that. Kick it with one of the little legs. All right, so I can get that soldered, hopefully. If I can find a place where this thing will sit and not move all over the place. Hold still, stupid thing. Come on. It just doesn't cooperate. Perhaps this will work. Oh, that is so nasty. It's so sloppy. All this work is so sloppy. The goal right now is not to make it pretty, it's just to get it done. I can't see a thing. Oh my god. It's gonna think I'm so whiny. This bother guy is streaming on YouTube and he's got these, he's so whiny, complaining about everything. Now it needs to move over, but it actually won't move because it's anchored in 2 spots. So we'll just see about getting that very haphazardly soldered in. I'll have to make sure that that wire doesn't contact ground. There. Just give it a little bit of space. Actually, I'm going to push that one forward a bit more. Okay, that is contacting. Nope, and the camera's totally off. I know, seriously, this is a big deal. Why have they not made these plastic skull heads easier to work with? I think I have a thing of solder shooting out of the back of that. No, that's okay. All right, 2 more pins and then we're golden to test this thing out. Oh my god. This is... I'm getting mad. I'm getting very mad. Look all right? No. It looks terrible, but it is connected unequivocally. So, all right, let's try that out. That's the full op-amp delete and dead diode replacement. It shouldn't have trusted those diodes. They're from like a 50-year-old, well, no, they're from like a 20-year-old power supply. And it could have been that the chip breaking busted the diode, but we can now, since this is on the other power supply, we can actually keep an eye on the current that it draws. So if I turn the VCO on and I turn the 12 volts on, 12 volts at 0.1 amp, so there's, why is it already hot? Oh, because I just soldered. Well, this is drawing current, actually. It's drawing way less current. That would have been, we were just very, very close to an explosion. We almost blew up. Because those get hot and then they gas out and then explode. So why was that getting hot? Oh, my anger, I killed him. Yeah, the diodes weren't fully, they weren't actually soldered in. So that one has to be connected there, and then this one has to be connected there. But what would the diodes be doing? I mean, we were drawing way less current, though. That was good. It's just that why would that capacitor be on the brink of exploding? Because it's not shorted out. I mean, that capacitor goes between power and ground. Oh, God, and it's still on. Let's turn this thing off. Now, it's not backwards because power comes in from here and it goes to this pin, which is the positive. Why would that be on the brink of exploding, though? No, it didn't bulge. It exploded. It would have exploded. Yeah, what does it matter if the diodes are connected or not? I mean, yes, it does matter, but it shouldn't blow up the whole power supply. And one of them goes to positive and the other one goes to negative. That's the one that goes to positive, and the other one goes, well, no, that one goes to the feedback, and it's still attached. Still connected the way that it was. It's just, what? There's no reason why. Nobody said brink. It goes to the world's ugliest power gang. Hold on, I gotta view what's going on here. Why would that cap get so hot? It's a like a 50-volt cap. The 50-volt cap. What are you doing? Better for worse, that is now connected. I think. Oh, maybe power was going through it weird because it was connected weird. This is a hideous fucking circuit. I probably could have done it closer to the forehead in order to make it work, but I wanted it to look cool. And looking cool puts it off to the side where it's hard to work on. All right, yeah, there's nothing else to the circuit. Like, I don't understand why the cap would have gotten that hot. That's kind of ridiculous. I'm going to turn this on again. I'm going to be careful, though. It's a 50-volt cap. Why would it be nearly exploding? Nope. Why is it getting hot when I'm not doing anything? What is happening here? Well, okay, I was just soldering right there. Let's let it cool down a little bit, and then our diagnostic will be appropriate. Because yeah, it's totally cut off from power when I turn it off. It's just the heat that's in there is from soldering. What's this thing doing being so warm? Why are you so warm? What's going on with you? This guy right here. Well, they're not hot. They're just a little warm. Huh. He's just pushing current. Doing work. We looking nice and cool now? This thing seems to have never recovered from getting hot. That's so rattly. Connecting to anything? No. Do that. do that with it. Pull it down there a little bit, make that a little tighter. Yeah, I don't really see any reason why this thing would be going all crazy like it is. Ah, wait, there's a connection. The 3 dimensions of my board are not working with me. No, that's not a connection. There's just a wire there. That's fine. Yep. Don't see why you're messing up so much. Why are you messing up so much? All right, let's try again. Yeah, having a hot cap like that is not something that should happen. And I don't know how that could have happened suddenly way under the voltage of the cap. All right, ready to turn it on again. 3, 2, 1, go. Okay, nothing happening right now because the switch is off. Switch on. Instantly hot on the diode. That is hot to the touch. Why? Why are you doing this? Speaker, diode. Speaker is over here. Oh, geez, the old chip is down here. I had that inside of the... Positive and negative on the speaker are fine. They're being brought over to here. Negative of the speaker goes to minus over here, which is what should happen. Speaker goes to ground. Diode 1 and 2. One of them goes all the way out here, where it goes to positive. Positive is not in contact with the case. It's soldered not that great. Okay, let's get solder on that. Now it's soldered better, but I don't think that's really going to help us. And then the other diode is connected to ground, and then it goes diagonally up on that part of the circuit to the other leg, which is also output. That there. And then that's the other leg here. Both diodes are heating up immediately. Like, what is going on? Look at that. Wait a minute, that's only that connection that got hot. What is there? Oh, that's where I just soldered. Duh. I keep making that mistake. Okay, turn it on, and it's that diode that's getting super duper duper hot. That's the one that goes to power here, and then the speaker here. I don't get it. I don't get what's going on here. They're 1 in 4007s, so they should be pretty resilient to this kind of thing. Where is that? Where's the other one? I don't know what happened to the old one. I was going to look and identify it. Because, like, yeah, I've been hitting it with a signal. A short at the speaker would be crazy. It looks fine. Is the cap getting warm? Cap's not getting warm, but I don't have any input signal here either. I'm not hearing my VCO, which we should absolutely be hearing it, because this thing is currently on. I don't know what's wrong with this. Wow, chat, I don't know. Don't know. Yeah, there's the speaker output. That's in perfect shape. It's not connected to anything else. And then, you know, some of the junctions on this thing are not really well done, but they're good enough. And if I don't connect things, well, how much current? Yeah, it's drawing 6 amps, and my power supply is dropping down to 2 volts. Having an ammeter. Well, look, you know, I don't know what the deal is. Because by all means, this should work just fine. But it's, for some reason, it's like practically shorted out when it connects, when it powers up. This little door for wires is very annoying. Also, I know it's shorted because the LEDs aren't, you can't even see the LEDs. So what is immediately shorting it is probably the diode, but are they like fully backwards? This goes to power, just diagonally like that. And this is also power, and then power goes to the capacitor. So that's pretty much all of the stops for power. Cap goes from there to there, and this is our signal line that isn't connected. I have to redo that signal line so that the knob runs in the right direction. But first, I got to get it to work at all. So see, that's not connected. It was in between the legs of the cap before. Now it's just standing up. I've got this whole circuit memorized by now. I know what everything is doing, and what it's not doing is working. Yeah, look at that. So as soon as it gets hit by 12 volts, ready? Click. The supply runs protection, basically. It even does it at 5 volts. Why would it do this? Why would it simply not function? Is it stupid? I don't get what I did. I don't know. It's got to be something I did, but I'm kind of out of candidates here. One, two, three, and that thing over there. Does it just need that much? It's an infrared diode. It's true. So power comes in, goes to common, or normally, yeah, common. Power comes in, goes to common. First stop. Second stop, it comes out of here. So this wire, well, this one takes it to 2 resistors that go to the LEDs. The other side goes to this suspended wire right here. And this, it's obnoxious, but it works. Well, it doesn't work. It doesn't work. It goes over to this right here. This suspended, disgusting looking wire, right? This is some of the crunchiest circuits that I've put together. So it then goes to the diode right there. That's the hole for the diode. Pretty sure that's the right one. Because the other diode is over here. Hold on, let me probe around a little bit. Yeah, see, this cluster is the one diode. And then this is the other diode right here, where it connects to ground. So that's sort of soldered. It's kind of sunk into the plastic there. And then power also comes up here across this, and I can't view it from the other side, but this goes up into the plastic over here and then pops up there. And then this is the speaker output running back to that pin. That's soldered. So the power also comes up here and goes to the capacitor. So audio comes in, get out of the way. Audio comes in through here. That's the 4.7 UF. That's the one that it gets through. Well, that might be a problem. This is 47 UF. Is it supposed to be 4.7 or 47? Hold on, let me look at the schematic here. What value is this? Of what value? Okay, it is 47. So yeah, okay. So 47 UF. Then we come out of that and we go through another one of the dirtiest fucking connections that I've ever done, where it goes under the power rail. Is that contacting? No, there's plenty of room. Yeah, the DC frequencies. Yeah, so it goes through there, and then it goes to the first resistor and the input to the rest of the circuit, right? It goes through there, and it goes to that junction on pin 1, where it both has a resistor to ground as well as a resistor. No, it has the capacitor, the resistor, and pin 1. So that's that pin right there. Capacitor, resistor, pin 1. Other side of the resistor goes to this spectacularly floppy. I've done better floating circuits than this, just rest assured. So by all means, this thing is properly connected. I think maybe the diodes that I used are cursed. I think they're completely cursed. Because they're just letting all the current through them. They're starting to smoke. They weren't doing that before. Jeez. Okay, I don't know what the hell happened with this project. Something got out of control. Something got out of control, and my cool skull speaker will have to wait for another session of troubleshooting. It's possible that I could do a surface mount thing with this. Maybe do a surface mount thing on the top of the skull. We could rip all this stuff out and start over. Yeah, you saw a little wisp of smoke. Oh, you were seeing that earlier? Yeah, well, the chip itself was heating, the amplifier itself was heating up so much that it distracted from the other components. I don't see... Does it heat up without the synth plugged in? Yeah, pretty sure. Hold on here. I won't actually be able to see whether or not... Yeah, it's still drawing a shit ton of current. Those diodes are going to burn up pretty quickly. There they start smoking. That's bad. Okay, turn it off. Oh, now it's starting to smell. Smelling like burning old diode. Yeah, the diodes are the right way. The diodes are a push-pull setup. So the way that I have them is... you have the chip like this. You have 5 leads coming out of it. And so this one goes to ground. And it also has the diode on it facing away. So that actually might be backwards. You're right. Wait a minute. Wait a minute. I think you guys are right. Because this is how I have it. And then this one loops to there. So that would be facing... No, that is correct. Yeah, no, that's correct. That is the right way. So yeah, I actually have this correct. Hold on a sec. That's hard to see. No, they both point away, guys. See, both of those are pointing away, and they're on pins 3 and 4, right? And so with them like that, and I probably should have drawn this bigger. But yeah, that actually loops over to here. So I'm gonna draw it bigger just so you guys understand what's going on. It's really confusing to me because this all should work just fine. 1, 2, 3. Oh, no. And then you have diode. And then you have diode. And then there's a dot. And then that one goes here, and then this one goes there. That is how I wired it up, right? And that is the same thing that's here. Can't show them both at the same time. So there we go. So yeah, if you look, it's like positive voltage on the cross goes into the cathode of the first 4007 down to pin 4 on the other side of the 4007, where it also connects to D1 at the cathode, and then that goes to ground on the anode. So yeah, those are correct. Why are they heating up? Weird. Okay, anyway, I'm done. I've finished. This is too frustrating. I'm not going to keep going. I'm going to be back on Thursday. Thursday is the next time that I stream. Until then, you guys can catch me on Discord. I also have, and social media. I don't know what it's called anymore, but you guys can check me out there. And Nightbot is down. Even the worst. What is happening? I spelled that right. Nightbot is not working, huh? Even Nightbot today. Why did the diodes explode like that, though? Oh, there it is. Just when I type it the second time. I don't understand why it's working. Oh, there it goes again. There we go. This is plaster my social media all over everything. Yeah, I don't know what's going on with the circuit, though. Very strange. I still have no idea how an op-amp works, but it looks correct. Yeah, it's just comparing two voltages and outputting what it can, what it sees. It's basically just like an equation. And so the way we use it is with feedback in order to create gain. You can look it up. There's circuits that'll show you how op-amps work, but I'm not great at explaining that in particular because analog stuff is new to me. I'm better with digital, but I'm learning. So, well, but we replaced the chip. Maybe the bad chip broke the diode. I don't know. That was very frustrating. Sorry to have it be so frustrating. That was supposed to be something that I could just slap together and it would make like a cool looking speaker. And by all means, it should have. It's just, I don't know, something weird is happening. And the fact that I slapped it all together makes it very difficult to kind of go through and do all the specific circuit elements. I think I've spread out and I used copper tape. Might be able to make a better speaker. I got to find a good circuit for that first. Until then,